electrostatics, just secondary topic I am teaching today, electrostatics. Just we are finding the interaction between the two charges when they are at rest in static condition, not in dynamic condition. So electrostatics, in electrostatics, definitely, but for electric field, charge is the main property, but it is not a fundamental quantity, but current is a fundamental quantity. So current is what? Amperes, the fundamental physical quantity. Now charge, I is nothing but what? Rate of charge flown. That is what we are finding. Current and charge will have relation like this. Now we are having charge. Charge is a property of matter and mass is also property of matter. Now this is matter. Now charge can exist. Charge can exist only mass is existing. So if mass is zero, charge cannot exist. So definitely keep, but charge is there, definitely there is a mass. So if mass is there, no need to keep charges also. Mass can exist without charge, but charge cannot exist without mass. Okay, these are the basic things. Now first, charge is quantized, charge is conserved, charge is invariant. So total charge is, suppose when we isolated, total charge is conserved. Suppose you take one system, charge is Q. So I can divide this into Q1 plus Q2 is equal to Q. I can divide, but total charge must be constant, and totally we cannot create and we cannot destroy charges. Now next one is charge is quantized. Minimum charge availability is plus or minus NE. So minimum charge availability in open nature is electron charge, that is 1.6 in 10 power minus 19 coulomb, and the charge is not a function of velocity. So mic online undamma. Now charge is not a function of velocity. Charge is not depends upon velocity of the charger particle. Okay, now you keep in mind, charge is conserved, charge is quantized, charge is invariant. These are the main things. Now charge can create field. Charge can exert force on another charger particle, and whenever charge is there, that influence is there in the world. Now in space also. Now charge creates, but Q1 and Q2 separated by distance d. According to Coulomb's force is what? Coulomb force between them is what? So Q is equal to, Coulomb force is equal to K 1 by 4 pi epsilon naught Q1 Q2 by d square. Now d square, the force between the two charges when separated by distance d is equal to 1 by 4 pi epsilon naught Q1 Q2 by d square. Now when we replace different medium, suppose two charges separated by distance Q1 and Q2, the distance between them is d, the force of attraction, but air is there now, but air or vacuum, both are having the force F1 is equal to what? 1 by 4 pi epsilon naught into Q1 Q2 by d square, that is Coulomb force. The force of interaction between them is remains same even when we replace the any other medium also. Suppose when we replace this value, you know, this value is how much? 9 into 10 power of 9. This value is 9 into 10 power of 9. So units. Okay, epsilon naught. This is a permittivity of free space. So this epsilon naught value is what? 8.85 into 10 power of minus 12. So in units you are able to say that is a Coulomb square per Newton meter square. So you can find the dimension formula of epsilon naught also, but 1 by 4 pi epsilon naught also you can find the dimension formula. So these units are what? 1 by 4 pi epsilon naught is equal to Newton meter square per Coulomb square. So just you find out now. So when we are replacing with another medium having some dielectric constant K, so definitely that is a relative permittivity. So epsilon naught by epsilon by epsilon naught. So epsilon is what? Just we are replacing the K times epsilon naught. When we replace other than air, so some different medium, so force between them, the force in only interaction force between them remains same as this only, but net force on one of the charger particle will change. That force on one is equal to force due to force on one due to 2 less force due to on one due to medium. So definitely you remember the force on one, net force is depends upon the medium between them, but force of interaction between them remains same even when we are replacing with the different mediums. So that is very, very important statement. Now always you remember, when we keep any charge in different medium of dielectric constant epsilon naught, how much charge will be induced? So minus q times 1 by 1 minus 1 by k times charge will be induced. You remember this one also. When we keep any charge, suppose this total medium is filled with epsilon medium. Now the epsilon is nothing but k times epsilon naught. This is what conductivity, dielectric constant. So epsilon is equal to k times epsilon naught. So when we replace total medium, but this charge can induce charges nearby this, those medium induced charges also exert force on this one. That force is nothing but what? Due to medium. So this will be q into 1 minus 1 by k will be there. So induced charge, when we keep q1 in different medium, induced charge will be there. That induced charge will be q times 1 minus 1 by k, minus sign. If it is a minus q, plus sign will be there. So plus q, minus sign will be there. So total charge will be induced. Now, what is the net force on charged particle will be always when we replace? So F1 must be what? F1 must be is equal to what? Total net force is equal to 1 by 4 pi epsilon q1 q2 by d square. You remember this one? So just you replace this, that is nothing but F2 this square, F1 by k times. So definitely when we are replacing any different other medium, the dielectric constant k, definitely force is reduced to 1 by k times. So force definitely when we replace, net force on any charged particle reduced to k times, 1 by k times. Initial force is F naught. When we replace the medium with the conductive dielectric constant k, definitely F naught by k. So definitely net force will be changing F naught by k, F1 by k. So you remember this one. Now, how these two charges are just exerting force on each other. So there is no physical contact. There is no physical contact. Definitely on. There is no physical contact. So there is no physical contact. So how they are exerting force on each other? Through field lines only. So charge can create field lines. So those field lines exert force on other charges. So now we are finding charges. Now take generally these forces also just I am giving. When we are replacing, suppose the charge is q, q1 and q2. So only this medium is exerting. Suppose thickness is t, but total distance is d. When we are replacing only partly, suppose dielectric constant is k. But what is the force between them? How to calculate? Just initially this medium is not there. Only partly we filled. But this is A, this is A. But total distance between them is d. But only thickness d, thickness t, when we introduce dielectric constant, some different medium, then force is nothing but always you remember that net force will be is equal to write down. Force F dash is equal to what? 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught q1 q2 by so r d minus t plus t into root k times whole square. This is what I am saying. So when we replace, so partly, so force will be equal to 1 by 4 pi epsilon q1 q2 by d minus t plus t root k times square. Now completely filled, what happens? Completely filled, d is equal to t. D is equal to t. So definitely these two will cancel. So d root k whole square. So what you are getting? Same. F naught by k times only. So always you remember when we replace partly, so this is the force between them. Net force, this is not a total interaction force. The force on one of the charged particle, on this or on this. So net force on one of the charged particle will be this. This is not the force of interaction alone, but this is a net force due to induced charges. So how much charge will be induced here? How much charge will be induced? Q1 is there, minus Q1 into 1 minus 1 by k times. So here Q2 is there. How much charge will be there? Minus Q2 into 1 minus 1 by k times. So charge will be induced. These charges also exert force on existing charges. You keep in mind that. Okay. Now coming to electric field. So charge can create electric field point charge at additions are just field is kq by field at point P is equal to k. K is 1 by 4 pi epsilon naught. Just this you consider k is equal to not dielectric constant. So k into q by r square. So this is what, but in vector form, just we are writing E bar along radial direction. So E is equal to 1 by 4 pi epsilon naught. K is equal to what? K is equal to 1 by 4 pi epsilon naught. So q by r square, just in the direction away from the charge. Now if it is a negative charge, but minus r. If it is a negative charge, minus r is there always towards. So field lines are going away from positive charge and coming towards negative charge. So now due to this, definitely we are finding charge just field at point Q. Suppose when we are bringing other charge, this is R1, this is R2. Then what is the field at this point? Field at a particular point due to charge 1 is kq1 by r1 square. Due to this kq2 by r2 square. But field at a particular point, but due to this charge will not change when we are bringing other charges nearby this. So this direction is what? E1 is along this direction, E2 is along this direction. So the result angle between them is say theta. So definitely we are finding resultant electric field between them. So electric field at a particular point is following superposition principle. Electric field at point P is equal to E1 bar plus E2 bar. So we are writing vector form only. But when we are finding magnitude, so definitely E1 square plus E2 square plus 2 E1 E2 cos theta under root. We are getting. So mod electric field is equal to root over E1 square plus E2 square plus 2 E1 E2 cos theta. This is what I am saying. So electric field at a particular point due to charge is remains constant, direction also, magnitude also. But when we are bringing, so net field at any point will be changing due to superposition principle. But due to this charge remains same. Due to this charge remains same. But resultant will be, but in one direction, that may be the EP. So it can follow the parallelogram law, vectors only. So due to point charges, we are able to get a net electric field at any point. Next, due to line of charges. Line of charges means so. Always you keep plus charges given to this, but charge is given Q. Total charge is given Q, but length is L. So whenever charge is distributed linear wise, you find out charge per unit length. But area, sheet area you take, area, but area is given, then you take sigma, sigma is equal to Q by area. So when volume charge is given, density rho, rho is equal to charge per unit volume. So always you remember, but whenever charge is distributed, just you find out linear charge density, aerial charge density and volume charge density. First, how, on which surface they are giving charges. So line of charge, sheet of charges or finite boundary, but like spherical surfaces, like cylindrical surfaces, cone. So definitely volume we have to find, volume charge density. Now these are the main things. Each and every charge creates electric field at any point. Now this charge is what? Linearly distributed. This charge is area wise distributed. This charge is volume wise distributed. So due to all these three configuration, how we are going to get field at any point? So field due to line of charge at any point will be lambda is given. Means what? Lambda per unit charge per unit length. That additions are R is a perpendicular distance only from the wire. So electric field at point P is equal to Gutunda lambda by 4 pi epsilon naught sin alpha plus sin beta. So this alpha beta is what? Beta, this alpha. So electric field at any point, we are able to get electric field perpendicular direction. So along this direction, this is what electric field along this direction must be lambda by 4 pi epsilon naught sin alpha plus sin beta. But this field is, this component is perpendicular to wire. Perpendicular to wire. Now, if alpha is not equal to beta, definitely field must be there along this direction also. Now, E electric field at point P along this direction we can consider, so parallel to the wire must be lambda by 4 pi epsilon naught cos alpha minus cos beta. This is a very important point. Now field must be there, parallel and perpendicular to the wire. So if alpha is equal to beta, this term becomes 0. Only field is perpendicular to wire only. So you remember this formula, lambda by 4 pi epsilon naught sin alpha plus sin beta perpendicular to that, parallel to that lambda by 4 pi epsilon naught cos alpha minus cos beta. Now, but sometimes here alpha is negative. Alpha is negative. But beta is positive. Cos of minus alpha is positive only, okay? But anyhow, where we are taking integration, but beta is greater. This field is always, you remember, but this parallel field is always, if alpha is less, along the direction. If alpha is more, opposite to that, parallel direction. But you can confuse. But cos alpha minus cos beta na, cos beta minus cos alpha na. So always you remember cos alpha. So if alpha is less than beta, alpha is less than beta, field is in which direction? So always you remember. So this can exert force. More, alpha is less than this, definitely you take cos alpha is more. So always you take positive sign, but alpha is less along this direction, alpha is more opposite direction. Alpha is less, here alpha is less than beta in this case. So field direction I am showing here, alpha is less than beta, so cos alpha is greater than cos beta. Now field is along this direction. Due to this wire we are getting. Now this wire we can replace with a simple concept, but arc length wire. So this radius is what? Simply I can replace this arc length wire. Due to this pink color wire and due to this wire will have the same field. So field due to this each and every element is what? At what distance? The field must be in particular direction. This field must be along this direction. So due to this bisector line only. This is always alpha plus beta by 2 direction. So we are able to get this component simultaneously like this only. So always you remember. But due to arc length wire, the field is same as this. So, but whenever straight conductor, infinite conductor, alpha is equal to beta, your answer should be, but this parallel component will be 0, only this component is existing. So how much? Lambda by 2 pi epsilon naught sin alpha. Lambda by 2 pi epsilon sin alpha. So you remember that one, okay? So alpha is equal to beta is equal to pi by 2. What do you say about this? Infinite wire. So alpha is equal to beta is equal to pi by 2, infinite charged wire. Due to infinite charged wire, this term becomes 0. Parallel becomes 0. This term becomes what? This is the lambda by, due to infinite charged wire, lambda by 2 pi epsilon naught r. So, but perpendicular to that direction is what? So you always remember now. Next one. Coming to ring. Coming to ring. When we take a ring, charge density is lambda, means total length is what? 2 pi r. Ring. So how to find field at the center? Field at the center of the ring is always 0, because, but you take one element here, this element will produce field along this direction dE, but you take opposite element, it will produce opposite direction. So field due to charged conducting wire at its center is 0. Field at center is 0. Now when we are moving along this axis of the ring, passing through center and perpendicular to the plane also, but when we are moving along this at a distance x, so say this is a ring, this is a center at a distance x, this point is P. So how to calculate? Lambda is given. The field at point P is EP is equal to K 1 by 4 pi epsilon naught, just Q. Total lambda is KQX by root over x square plus r square whole power 3 by 2. X is KQ x by x square plus r square, capital R square. This is r, you can take. So always you remember. So field is what? Due to this one, KQ by r square. KQ by r square. KQ by r square. When we take just integration, we are getting this one. Electric field at any point P on its axis is, it is a positive charge, away from that. If it's negative charge, towards its center. So electric field at this point will be K 1 by 4 pi epsilon naught Q x by x square plus capital R square whole power 3 by 2. Now total length of the ring is what? Lambda. 2 pi r. 2 pi r charge per 2 pi r is equal to lambda. Just Q is equal to what? Substitute here Q is equal to what? Lambda into 2 pi r. In this one, when you are substituting in terms of lambda, electric field at point will be is equal to 1 by 4 pi epsilon naught into Q is equal to what? Lambda into 2 pi r into x by x square plus r square whole power of 3 by 2. So just 2 pi will cancel now. So this is what? Lambda r x by 2 pi, 2 epsilon naught, 2 epsilon naught root over x square plus r square, root కాదనుకుంటా, whole power 3 by 2. X square plus r square whole power 3 by 2. Just replace, enough. But you remember this formula only. Electric field at point P is equal to due to charge ring. So K Q x by x square plus r square whole power 3 by 2. Just field at center is 0. Field at infinity will be 0. Field at center is 0. Field at infinity also 0. So in between field is not 0. So definitely field is increasing to maximum value, again decreasing. So again the field due to charge ring is always varying along the axis. So first it will increase and it will increase in the opposite direction. But here we are getting x is equal to r by root 2. So when we differentiate and equate to 0, field become maximum. At maximum dE by dx is equal to 0. Then definitely x is equal to r by root 2 we are getting. So x is equal to plus or minus r by 2 we are getting maximum field. So this is important now. X is equal to r by 2. If radius of the ring is r, where you are getting maximum field? At r by root 2 from the center on the axis. But opposite. Same. But here also we are getting same. Now take two charges separated, Q1, Q and Q. But where you will get maximum field along the axis? So the distance between them is what? Say 2d. You assume, but these two charges on the ring. Due to ring, where you are getting maximum? R by root 2. So this is R is what? D. So definitely here you will get maximum field. So E max is at D by root 2. Total length is D, D by 2 root 2. Like that you will get. Now take sheet like this. Charge is given sigma. Charge will be reside on the outer surface of the body only. Just I am not talking about potential charge. Due to this, how to calculate field? Just due to sheet sigma by, but due to thin sheet sigma by 2 epsilon naught, normal direction. Sigma by 2 epsilon naught. Due to sheet, electric field, thin sheet, sigma by 2 epsilon naught, but radially outward. If it is negative charge, towards charge. So electric field is like this. Any conductor is given. So field is always just open field is so electric field due to disk and ఇప్పుడు derive చేయడం కష్టం కదా, just you write the formulas only, okay? But field due to any charged configuration at any point we are able to get, but by using, so electric field at any point will be due to any charged configuration, K integral dq by r. This is important now, okay? So if any charged configuration is given, but we are able to get field at any point, so derivation is impossible, but we are not having time. So electric field at any point will be, so due to charge, but at a distance r, we are able to get just dq by r only. dq by r. This is important. Electric field at any point, we are able to get by using this. K is equal to what? 1 by 4 pi epsilon. So when the medium is changing, so just we are replacing with the 1 by 4 pi epsilon. So field at any point, we are able to get kq by k dq by r. R square, not r. kq by r square. not potential. Now, coming to Gauss law. By using Gauss law, just electric field at any point we are able to get by using Gauss law. ds bar is equal to charge inside by epsilon naught times. This is very important topic. The electric field, suppose you take charge here, Q, how many field lengths it can contain? How many field lengths can it exhibit? Q by epsilon naught. Q by epsilon naught. So whenever we are keeping any charge, suppose you take shape is circular, shape any other charge. Suppose Q I kept inside, Q also. But how many field lengths are crossing over this surface? Q by epsilon naught only. But here also Q by epsilon naught. So Gauss law, when you are finding, Gauss law finding is what? Independent of flux is independent of shape of the Gaussian surface, size of the Gaussian surface. Flux is always constant, but whatever it may be the value, but E bar dot epsilon naught, E bar dot ds value, that is charge inside the Gaussian surface by epsilon naught. So here electric field are finding this is not only due to inside charges, but it can find by using just Coulomb's law. This field is due to outside charges also. This is called flux, electric flux. The flux is always defined as number of field lengths crossing per unit area. Just we are finding flux. This you remember. So how much flux is passing through this one? Due to this one, Q by epsilon naught. So if it is minus charge, but how many field lengths are going to terminate on this one? But towards charge, minus Q by epsilon naught. But charge is what? But flux is what? Number only. Flux is number only. But how much a flux is contained? Flux means the number of field lengths. But if the positive charge going away, but negative charge towards. So flux is what? Flux is negative means what? Field lengths are, flux is negative means, suppose field lengths are entering, area is opposite direction, but E bar dot dsp is nothing but what? Flux is open surface. Flux is equal to E bar dot ds bar. So electric field and area vector in opposite directions, cos 180, E ds cos pi. So cos pi is what? Minus 1. So whenever field lengths are entering, the minus sign indicates field lengths are entering. So plus sign indicates field lengths are leaving. So flux is always negative, means field lengths are entering onto the surface. So whenever field lengths are entering, you take flux is negative. When field is going away, the flux is positive. So you remember this one, negative and positive. When we are taking, flux is entering, negative, flux is leaving, positive. So by using this, we are able to get field at any point. So if this one is existing now, you can consider flux. Suppose you take charge, uniformly charged disk, sphere. Uniformly charged sphere, just rho, but radius to, just radius is r. If r is less than capital R, field at any point inside will be what? Field at any point will be rho r bar by 3 epsilon naught. You remember this one. This formula is very simple formula. So electric field at any point inside at a distance r will be rho r by 3 epsilon naught, just away from that. Positive charge away, negative charge towards. So just outside, when we are finding outside, next if r is greater than r equal to also you can take. Electric field at any point will be is equal to what? So this is one, this point. So how to calculate? Total charge is how much now? Total charge Q is inside. Q is inside. So total charge you can calculate Q is equal to what? Rho into 4 by 3 pi r cube. So K Q by r square. Simply, when we are going outside, but field lengths are coming from the center only, it will appearing to a person standing at this point. So here total charge is what? K Q by r square. Substitute K. Q is what? Rho 4 by 3 pi r cube by r square. So this is what? 1 by 4 pi epsilon naught you are having. So electric field outside will be, electric field is equal to, this is 1 by 4 pi epsilon naught. So how much you are getting? Rho r cube by 3 epsilon naught. Rho r cube by 3 epsilon naught into 1 by r square. Electric field outside is rho r cube by 3 epsilon naught 1 by r square. Electric field inside rho by 3 epsilon naught r bar. So inside it is proportional to r, outside it is proportional to 1 by r square. So you remember this one, okay? Now coming to potential. So potential, when you take a shell, shell means what? There is no charge, but shell. Due to shell, how to calculate field? Shell. Shell, field inside is always 0. Field outside, it can follow like kq by r square only. So outside is also like kq by r square. But shell means what? Charge is volume-wise distributed or area-wise distributed? Area-wise distributed. So sigma is equal to what? Sigma is equal to charge per unit area, 4 pi r square. So charge is how much now? So whenever shell is given, just charge q is equal to what? Sigma. Sigma 1 by 4 pi epsilon sigma into 4 pi r square by small r square. So due to shell. Shell inside point is always field 0. There is no charge. But according to Gauss law. Gauss law is 0. Next, coming to potential. Potential, how to calculate? So potential, when we are keeping charge, finding potential at point P at a distance r. So bringing one charge from infinity to just at a distance r from the charge q. Test charge. Test charge is what always you take? Unit charge, 1 coulomb unit charge. Positive charge is called test charge. Work done by the external forces bringing charge from infinity to this particular distance r. Per unit charge is nothing but work done. Work done per unit charge is nothing but potential. That potential is nothing simply kq by r. Write down this one. Simply kq by r. If positive charge, keep plus sign. Negative charge, minus q. Potential at any point will be potential is a scalar, kq by r. Now, what is the relation between potential and electric field? So electric field is defined as negative potential energy gradient. So dV by dr. So E bar is equal to minus dV by dr. So this is a very important one actually. So we can find electric field when we have a potential difference. If potential difference is 0, electric field also 0. So that is called potential difference is 0, electric field is 0. So electric field is 0 means what? Means dr is not 0, potential is 0, potential difference is 0, electric field is 0, means potential difference is 0 means 1 minus 1, 0, 2 minus 2, 0 minus 0, 0. We are getting potential difference 0 means potential is not 0, potential is constant. Potential is constant, then electric field will be 0 inside. So means whenever we take a conductor we consider conductor when we give charge. So conductor is what? But if charges can move freely, but when we are depositing some charge here, but these two charges will repel each other, move away from that actor. So this conductor is behaving like a constant potential surfaces. So equipotential surfaces. So whenever potential is constant, so electric field must be what? 0. Inside the conductor under electrostatic equilibrium in equilibrium condition means electrostatic equilibrium, all charges are separated or just the distribution is fixed. Charge at any point is constant, that is called steady state. But in equilibrium condition, electric field inside a conductor is always 0, means potential is constant. So each and every conductor behaves like a constant potential regions, okay, surfaces. So electric field is 0 when potential is constant. If potential is 0, but need not, if potential is 0, electric field may not be 0. But if potential is not 0, but electric field may be 0. But when we take a dipole, we will get that one, okay. See, electric field and potential relation is always E bar is equal to minus dou V by dou R along radial directions. Due to point charge kq by r. So when we are having two charges, so charge is at this is r1, this is r2, q2. But how to get potential at any point? Potential is a scalar, simple additive only. K q1 by r1 plus k q2 by r2 like that. So potential is a scalar, we can add, but it is not a vector, but you can simply add. If the plus sign, keep plus sign, minus sign, keep minus sign, just you will get. Potential at any point due to two charges may be 0 also possible. When we take two different negative charge, one is positive, one is negative, definitely at any point we are getting, at a particular point we are getting potential is 0. Now, when we are releasing one charged particle in external electric field, uniform electric field, non-uniform electric field. How to define uniform and non-uniform? The space between any two field lines constant, that is uniform. The space between two field lines is keep on changing. Definitely it is uniform or non-uniform. It is non-uniform electric field. But this is what? It is also the space between the two field lines is not constant, varying. So definitely non-uniform electric field. The space between them is remains constant, that uniform. Uniform means magnitude and direction is constant. When we are releasing one charged particle, positive charge, how it will move? When we are releasing, the charged particle will move along the field line direction. Positive charges move along the field line direction. So definitely when we are bringing, so definitely when we are writing this is V1 and V2. So already I wrote, but E bar is equal to minus dou V by dou R along radial direction. So field is always just directing in the decreasing potential directions. So now you tell me, but V1 is greater or V2 is greater? Electric field is always in the direction of decreasing potential. So V2 is greater or V1 is greater? V1 must be greater than V2. So definitely field will be along the direction. This surface is called equipotential surfaces or plane. This is also equipotential plane. This potential is different, this potential is different. When we move along the field line direction, potential will decrease. When we move along the potential direction, field direction, potential will decrease. So when we release any charged particle in uniform electric field, that positive charged particle always try to move in the decreasing potential direction. So whenever it is moving in the decreasing potential direction, definitely electric field exert force on charge. That charge, the force can do work. So that work done is nothing but what? Electrostatic work done, E into Q into dx. That work done is nothing but change in kinetic energy. So whenever we are releasing any charged particle, that charged particle will exert force, experience force due to electric field, but moving. So whenever it is moving, work done is done. This is work done by electrostatic forces. It is a change in kinetic energy. So work done by electrostatic forces always changes only magnitude of velocity. It cannot change the direction. Electric field cannot change the direction of the charged particle, but only just component. Suppose uniform electric field is a, definitely that charged particle try to move, this electric field always changes the magnitude of the velocity, not the direction of the velocity. Magnetic field always changes the direction, but is not changing the magnitude. So electric field always changes the magnitude of velocity, means can do work, it can change the kinetic energy. So if I am releasing negative charged particle, what happens? Negative charged particle always moving against to, negative charged particle always moving against to electric field. So negative charged particles are moving towards increasing potential directions. Positive charged particles are always moving in the direction of decreasing potential. Negative charged particles are always moving towards increasing potential directions, moving against electric field. Moving against electric field. Then also increasing kinetic energy. So work done by the electrostatic forces or electric fields on any charged particle changes its kinetic energy. Means changes its magnitude of velocity, not direction of the velocity. Now, so whenever this is moving by a distance d, so E Q into E into dx is nothing but what? Change in kinetic energy. Now you tell me, but E into dx is what? E is equal to what? Minus dou V by dou R. So here dou V by dou x I can take. E into dx is what? Delta V. Suppose when we are changing E into delta V is equal to delta Ke. Whenever charge is moving through a potential difference delta V, it gains kinetic energy. It can decrease kinetic energy. Changes kinetic energy, delta Ke. Q into delta V is equal to delta Ke. This is important formula. So Q into delta V is equal to delta Ke. This is noted. Negative charge, you keep negative sign. Now dipole. Dipole. Now before that potential energy. So potential energy between the two charges is what? Minus Q1 plus Q1 and plus Q2. the potential energy between them is, always you are writing D. The interaction potential energy is what? U is equal to K Q1 Q2 by R. Substitute with the minus sign or plus sign. It is minus Q1, keep minus 1. Plus Q2, keep plus 2. Total energy is what? Negative. So potential energy between the two charges we are defining like this. So potential energy is also potential into charge Q. Potential into charge Q. Potential energy is equal to potential due to other charge into Q2. Potential energy per unit charge. Potential energy per unit charge is also potential. Potential energy and potential both are scalar quantities only. Now, when we are bringing other charges, so Q3, so this is D1, D3, D2. What is the potential energy between them? Potential energy is how to calculate? So how many pairs are there? The interaction 1, 2, 3 pairs are there. So definitely we are getting potential energy is equal to what? K Q1 Q2 plus by R1 plus K Q2 Q3 by R2 plus K Q3 Q1 by R3. So that D3 or D1 D2 in here value. So this is how many pairs are there? 3 pairs are there. How many terms you are getting? 3 terms. Suppose when we are bringing 4 charges, suppose Q4. But how many terms we are getting? NC2. How many charges are there here? 3 charges. But potential interaction between 2 charges. How many pairs we are getting? 3C2. 3C2 means what? 3 only. Suppose next when we are bringing 4 charges are keeping. How many terms we are getting? 4C2. How many? 6. 4C2, 6. So definitely how many terms here in potential energy is existing you can consider. So 4C2. And C2 terms will be there. Next. So here potential is V1. We are keeping charge Q. So total energy is always defined as 1 by 2 times V11, V22, Q2 like this. This is the potential energy. General formula is V11 Q1, V22 Q2 by 2. So potential at a location of charge Q1 plus potential at location of charge Q2 is V22 by 2. This is the total potential energy of the system. Now dipole. Dipole is what? We are separating 2 charges plus Q and minus Q by small distance d. So due to this dipole, this is what? This is axial point. This is a bisector line. Axial point at a distance r, small r, point P. This is Q. This is small r only. Now how to calculate? Dipole moment is what? Dipole moment P bar is equal to Q into distance between them is d. So in which direction? Negative to dipole moment direction is always in the direction of negative to positive. Dipole moment, this is important. Dipole moment, electric dipole moment is always negative to positive direction. That is P is equal to Q into d bar. Q into d. This dipole moment will create field. Net charge is what? 0. But from the center at a distance r. But electric field, but r is very much greater than d. Electric field at point P, axial point, will be always writing K 2 P bar by R cube. 2 Kp bar by R cube. You remember this one. Dipole moment is P. K is equal to K into 2P bar by R cube. Now here, dipole moment is opposite to, just electric field is opposite to dipole moment, that is E at Q is equal to minus K P bar by R cube. R is very much greater than D, you consider. But dipole moment, due to dipole moment along the bisector line, field is opposite to the dipole moment. But here along the direction of the P dipole only. But here also along the direction of the dipole. But always remember along the axial points, field is in the direction of dipole moment only. But the dipole moment direction value will be, electric field will be K into 2P bar by R cube. But here Kp bar by R cube opposite direction. So net field will be, but you are finding at any point here. at any point here. Here this R, but making an angle theta with the dipole. The angle between the dipole moment and R bar is theta. So electric field at this point will be just magnitude E is equal to EP is equal to Kp by R cube. Just P by R cube into root over 1 plus 3 cos square theta. 1 plus 3 cos square theta. You remember this one. So formulas అడుగుతాడు జస్ట్ ఏంటంటే మొత్తం ఎలాబరేట్ చేసి చెప్తున్నా మీకు ఎలా ఉంది అనేది. జస్ట్ this is due to dipole we are able to find this one. Now tell me potential. Potential is what? Plus q, minus q and plus q, but here equidistance. Potential becomes what at this point? 0. Potential is 0, but electric field is not 0. Possibility is there or not? The potential is 0, field may not be 0. But when we take a dipole along bisector line, potential due to ideal dipoles are 0 at any point. But field at that point is not 0, but opposite to electric field, dielectric moment, dipole moment. Here potential is not 0. So here Kp due to point charge Kq by R square, but due to dipole Kp by R cube into root over 1 plus 3 cos square theta. Potential at any point P will be Kp by R square cos theta. You remember this one. Kp by R square cos theta. Potential at any point. Suppose you take this point, but angle between them is 0. But potential at this point is Kp by R square. But here minus sign will be there. But here 0. Kp by R square into cos theta. Cos theta is the angle between R bar vector and P bar vector. So potential amade. Potential at any point will be Kp by R square cos theta. When we keep two dipoles like this parallel to each other, P1 and P2, so they will exert force, repulsive or attractive. But dipole moment direction is plus minus to plus only, minus to plus. So like charges are closer than unlike charges, definitely they repel each other. They repel each other. When we keep two dipoles parallel each other, parallel to side by side, definitely they repel each other. But in anti-parallel directions, definitely it is anti-parallel. This is plus, this is a plus, this is minus, this is minus. Definitely like charges are, unlike charges are closer than like charges, definitely they will attract each other. So when two dipoles placed parallel to each other, they will repel opposite direction, repel opposite direction, attract. In the same direction like this, when we keep dipole like this, then P1 and P2, they repel or attract. So this is a minus sign, this is a plus sign. This is a minus sign, this is a plus sign. Like charges are closer than unlike charges. Unlike charges are closer than like charges, definitely they attract. So when we keep parallel to, they will attract. When we keep in opposite direction, P1 and P2, then this is minus, this is plus, plus, minus. So like charges are closer than unlike, definitely they repel each other. When we keep dipoles like this, they will attract. When we keep dipoles opposite direction, they repel each other. These two attract and repel, opposite direction. So dipole's alignment is also very important now. So torque acting on the dipole is what? How to calculate torque? When we keep uniform electric field is existing. This is the external uniform electric field. When we keep dipole like this, dipole moment, angle between them is theta. So torque acting on this is what? Torque is equal to P bar cross E bar. Torque is a vector quantity. The torque is always perpendicular to E bar and P bar. So torque try to rotate the dipole. So where the torque is 0, but when theta is 0, this is PE sin theta. Net torque will be, magnitude will be PE sin theta. If sin 0 or sin 180, torque is 0. When dipole is along the electric field direction, torque is 0, and a dipole is opposite that, torque is 0. But torque is 0 means it is not in, it is in equilibrium. Which type of equilibrium? Rotational equilibrium. But stable equilibrium or unstable equilibrium. Suppose when both are in the same direction, when we just displace like this, angle turn, it will oscillate and it oscillate about this one. So that is called stable equilibrium condition. When in opposite direction, it will come back to stable equilibrium position. It is unstable. So when angle between them is 180, theta is pi, unstable equilibrium, theta is equal to 0, stable equilibrium condition. Now, where torque is always acting to minimize the potential energy between them. Why torque is acting? Torque acting on the dipole when we are keeping an external electric field. Always try to minimize the potential energy configurations, okay? Potential energy. So tau d theta. Potential energy work done is nothing but what? Work done is tau into d theta. Rotational work done is tau into d theta. When we are keeping, that is nothing but potential energy minus m bar dot b bar. This is very important. Tau d theta. Theta 1 to theta 2. So same P E sin theta d theta. When we take integration P E cos theta, minus sign will be there. So P E cos theta is nothing but what? P bar dot, P bar dot magnetic field pen minus P bar dot E bar minus P bar dot E bar. So in same magnetic field also same. P bar dot E bar. Minus sign indicates that what? Opposite. So always the potential energy is a minimum, both in the same direction. Electric field and potential, electric field and dipole both in the same direction. So maximum, opposite direction. So always. So this potential energy always in between potential energy is always in between minus PE to plus PE. Sometimes it may be 0 also. Minus to plus definitely changing to 0 also. So potential energy is the minimum, that is stable equilibrium condition. Potential energy is maximum, unstable equilibrium condition. So when we are rotating from theta 1 to theta 2, so PE cos theta 1 to PE cos theta 2, you take difference. Minus PE means what? PE cos theta. P bar dot E bar means so. PE cos theta, scalar product. Energy is a scalar. So remember, when we are keeping dipole in the external electric field is non-uniform. So when electric field is non-uniform, so here electric field is non-uniform. The space is not constant. Here electric field is but here you take, but number of field lines are 3. But when we take here 1. So when we move away, definitely field lines are decreasing. When the space between the two field lines is increasing, the field is decreasing. So here field strength is more, here field strength is less. So here magnitude is, so here we are taking one equipotential surface, here also equipotential surface. Here V1 and V2. So which one is what? Always electric field is moving in the decreasing potential directions only. V1 is greater than V2. See, when we are keeping one dipole in this direction, suppose you keep dipole like this. Dipole minus sign, plus sign. Dipole moment is along this direction. Here field is more, here field is less, even small distance is there. So small distance is there. So force on this negative charge is more because the electric field is more here, this is less. Repulsion is less, attraction is more. Always when we are keeping dipole in non-uniform electric field, that dipole is always moving towards increasing electric field. Very important statement. So when we are keeping positive charge always moves in the decreasing potential directions. When we are keeping dipole in non-uniform electric field, that dipole always moves against electric field in the increasing electric field directions. So always moving towards increasing potential directions. This statement charles are lichunar actually. So dipole etla move avutundi? How dipoles will move? Dipoles will move opposite to electric fields or increasing electric field directions. So how electric field is increasing? But see, field strength is increasing in opposite direction only. Suppose when we are keeping like this, suppose this dipole will move along this direction. Suppose when we are keeping like this, is non-uniform electric field only. But when we keep dipole like this, minus and plus, so dipole moment is along this direction. How it will move? So here, but it is unstable only, but this force is more, this force is less, because here strength is more, electric field, here strength is less. Definitely, in which direction it will move? Repulsion, opposite direction only. Dipole, this attraction is less, this repulsion is more, definitely net force is along this direction. So when we are keeping any dipole in non-uniform external electric fields, always moves against electric field. Okay? Now coming to capacitors. Capacitor is what? Capacitor is just two charges are separated. Parallel plate capacitor, negative charge, negative charge. So this is a plus Q and a minus Q. Total charge inside is always 0, but charge means one of the plate we have to consider. When we are connecting to source, so potential difference is V, when switch is closed. So capacitance is always defined as capacitance is equal to C is equal to Q by V, potential difference. See, now, but we are talking about charge and potential, but capacitance. So when we change conductor, you take conductor, when we give some charge, definitely there is a potential. So potential means what? V. V is equal to what? V is equal to KQ by R, just when we take a charge. Generally, when we are taking this, but potential is proportional to charge Q. Potential is proportional to charge Q. Our charge is proportional to potential difference. But when we are taking charge is more, potential is more. Charge is less, potential is less. So now Q is equal to what? C into V. But C is equal to what? Q by V. But it is getting capacity is different, capacitance is different. But each and every conductor have a capacity to store the charges, to keep the charges on that. But each and every conductor is not a capacitor. But each and every conductor have a capacity to hold the charges. But each and every conductor is not a capacitor. But capacitance is always defined Q by delta V. Q by C is equal to Q by delta V. But C is proportional to Q. C is proportional to 1 by delta V. But don't talk like that, okay? But capacitance only depends upon the material and charge between the two charges. And capacitance is independent on charge and potential difference. But formula lo meeku kanipistundi, etla kanipistundi? Q is equal to CV. C is equal to Q by V. Charge double aithe keep potential constant. Charge double aithe capacitance ఏమవుతుంది? Double అవుతుందా? No. Capacitance is independent of charge and potential difference. When you increase the charge, definitely potential difference will change. Q by delta V is constant. Charge and potential difference both are interrelated, but capacitance is a ratio Q by delta V. Capacitance depends upon the shape and size of the conductors and a medium between them, not on the charge and potential difference. So, good to peట్టుకోండి. This is a parallel plate capacitor. The area of the plate is A and a medium between them is epsilon naught. So, capacitance is defined as epsilon naught A by D. Parallel plate capacitor, capacitance is always epsilon naught A by D. How you are getting this? Just you take charge. Charge, conductor is given. So, say Q is equal to what? Sigma. Q by A is equal to sigma. So, charge upon this one is sigma by 2 epsilon. Due to this, field is what? Sigma by 2 epsilon naught. But due to this also sigma by 2 epsilon naught. So, when we are adding, field is nothing but what? Field inside the capacitor is under sigma by epsilon naught. So, dV is equal to what? Minus integral E bar dot dr bar. Just we are taking. So, dV is equal to E bar dot dr bar. Just A to B. Q1 to Q2. Now, when we are taking sigma Q by A epsilon naught, E is equal to V by D. Delta V by D. Delta V by D is electric field is equal to sigma is equal to Q by A epsilon naught. So, delta V is equal to Q D by A epsilon naught. So, Q by delta V becomes what? Q by delta V becomes epsilon naught A by D. That is called capacitance. Always remember. Capacitance is always finding by taking potential difference only. You find potential difference, you will get capacitance directly. Now, parallel plate capacitor is like this. Now, you consider two plates are given. So, this is one plate, this is another plate. This is A1, this is A2. A2 is greater than A1. So, then what is the capacitance between them? The distance is D, epsilon naught medium is there. Yeah, what is the capacitance? Always you consider A1 is less than A2, then you take A1 only. So the capacitance between them is what? C is equal to what? Epsilon naught A1 by D, not A2 or A2 minus A1 rather. Okay? Always this area is less, this area is more. Definitely field is sharing between these two only. Whenever field is sharing, we can take potential difference between these two only. So C is equal to what? Less area you have to consider. So epsilon naught A1 by D. Now take a spherical conductor. The charge is given Q. The potential on the surface is what? V is equal to what? K Q by R. Already I told you, but V is equal to K Q by R. At infinity, we consider one more conductor at infinity grounded. Potential at infinity will be 0. The potential difference between them is what? Delta V is equal to what? K Q by R. Now Q by delta V becomes what? Capacitance. Q by delta V becomes capacitance. So R by K. So R by K. R is what? R into 4 pi epsilon naught. So the capacitance of the sphere is 4 pi epsilon naught R. Q by delta V. So 4 pi epsilon naught R. The capacitance of the single sphere, isolated sphere is 4 pi epsilon naught R. Take this one. So when we have a shell, inside sphere, but outside shell we are having. When we are connecting through battery. So this is R1, this is R2. So potential of this, potential difference is V only. So always remember, when we are connecting, so this is plus Q and this is minus Q. Plus Q and minus Q. Potential due to this is how much? Potential on the surface is potential due to this plus potential due to this. Potential at 1 is equal to K Q by R1 minus K Q by R2. So V2 is what? Potential due to this is K Q by R2 minus K Q by R2. So potential difference delta V is equal to K Q by 1 by R1 minus 1 by R2. So Q by delta V is equal to what? Q by delta V is equal to, so 1 by K 1 by R1 minus 1 by R2. Substitute, you are getting 4 pi epsilon naught. 4 pi epsilon naught R1 R2 by R2 minus R1. This is what? When two conductors are separated, the capacitance becomes what? So one is sphere, one is another shell. So R1 and R2 given. Capacitance between them is what? Capacitance between them is 4 pi epsilon naught R1 R2 by R2 minus R1. R2 minus R1. This is very important. Two conductors are separated. Then you find out potential difference. Q by delta V gives capacitance. Now take cylindrical surface. Cylindrical surface. Two cylindrical surfaces are given, but radius R1 and R2 per funny unit length is given L. So charge is given plus and minus. So potential difference. But due to this, field at any point is what? Due to this charge, field at any point is lambda by 2 pi epsilon naught R. So just infinite charge conductor, when we take lambda by 2 pi epsilon naught R into dr, just to take integration, that is going to get delta V. Delta V is nothing but lambda by 2 pi epsilon naught ln R2 by R1. See, total length is what? L. So charge gives what? Lambda is equal to what? Lambda is equal to Q by L. So lambda is given Q by L. Substitute Q by 2 pi epsilon naught L ln R2 by R1. So delta V, Q by delta V is what? Q by delta V is equal to 2 pi epsilon naught L by ln R2 by R1. This is what? Two cylindrical surfaces are separated. The capacitance between them is 2 pi epsilon naught L by ln R2 by R1. You can get. Just you find out the potential difference. Q by delta V gives capacity. Okay? You understand, I think. So two capacitors are connected in series. What happens? C1, C2. Two capacitors are connected in series. Effective capacitance will be C1 plus C2 or vary value. So just don't think like resistances. So two capacitors are connected series. So which one is constant? Charge is constant. So think charge will be constant. Q is equal to what? CV. Charge is constant. So V is equal to what? V1 and V2. So potential difference V is equal to what? V1 plus V2. So V1 is what? Total capacitance Q by C net is equal to Q by C1 plus Q by C2. So 1 by C effective is equal to what? 1 by C1 plus 1 by C2. Good to wait, sir. So don't think like resistances. When two capacitors are in series, effective capacitance will be 1 by C effective is equal to 1 by C1 plus 1 by C2. If 3 are given, 1 by C1 plus 1 by C2 plus 1 by C3. N given, 1 by C1 plus 1 by C2 and so on, 1 by Cn. So if identical capacitors are given, connected in series, C1 is equal to C2 is equal to C0. Then C effective is how much? Two capacitors are connected in series, identical capacitors are connected. Then capacitance becomes what? So this is nothing but C1 C2 by C1 plus C2. C1 C2 by C1 plus C2. So that is what? C0 by 2. So when two capacitors, identical capacitors connected, effective capacitance will be decreased. So when two capacitors are connected parallel means potential difference is constant. Potential difference is constant. So we are connected to same source, potential difference is constant. So charges will be divided, Q1 and Q2. So how much charge is coming? Q charge is coming. Q is equal to what? Q1 plus Q2. So potential difference is constant. Q is equal to what? C net into V. C1 V plus C2 V. So definitely we are getting C net is equal to what? C1 plus C2. So when two capacitors connected parallel, so we are getting effective capacitance will be C1 plus C2. Series 1 by C1 plus 1 by C2 is equal to 1 by C effective. So when we are replacing some dielectric constant medium between the capacitors, so capacitance becomes what? So the thickness is T, distance between is D. So definitely connected positive plate and negative plate. So how much? What is the capacitance between? Initially nothing is there, C0. C0 is equal to epsilon naught A by D. Now some thickness material, dielectric constant is K is introduced. So then what happens? Effective capacitance C dash becomes what? C dash is equal to epsilon naught A by D minus T, D minus T, D minus T minus or plus. Now completely electric field becomes what here? Electric field becomes 1 by K times. So completely filled, so D is equal to T. So K times it will increase. So always remember C effective will be what? Epsilon naught A by D minus T plus T by K. Why we are getting plus T by K? Just electric field is what? Sigma by epsilon naught. Here sigma by K epsilon naught. Here sigma by epsilon naught. Just we are taking potential difference only. So epsilon naught A by D minus T plus T by K. If completely filled, D is equal to T. These two will cancel, D by K. So capacitance becomes K times. If completely filled, capacitance becomes what? Completely filled, if D is equal to T. So C dash is equal to K epsilon naught A by D. K times increase of net. So when we insert any dielectric constant, dielectric medium inside the capacitor, capacitance will be increased. Because D minus of something, denominator is decreasing, capacitance will increase. So for conductors, K becomes infinite. This is the dielectric constant of conductors is infinite. For conductors, K is equal to infinity. Now, here in capacitors, two things are there, but work energy theorem, when we are changing the distance between the two plates by applying some forces. So electrostatic pressure force is defined as pressure. Electrostatic pressure is half epsilon naught E square. Electric field with them. Pressure. Electrostatic pressure is half epsilon naught E square. So pressure is nothing but energy per unit volume is pressure only. So is equal to half epsilon naught E square. Whenever electric field is existing, there should be energy. Energy per unit volume is nothing but energy density. Energy density is called pressure, half epsilon naught E square. So whenever electric fields are there, definitely there is energy. That energy we can calculate U is equal to what? Half epsilon naught E square into dV. Just we can take energy, total energy. Now, when we are having capacitor, there should be electric field inside. There is electric field, definitely there is energy. How much energy is there? Energy stored in the capacitor is equal to half into Q into V, or half CV square, or half Q square by these three are enough. So energy stored inside the capacitor will be half QV, half CV square, or Q square by 2C. These three formulas are available. Where we are getting energy. So see, half epsilon naught E square means sigma by epsilon naught whole square into dV. dV is nothing but area into distance between them is d. Volume of the capacitor is what? Area of the plates into distance between them. So this is what? Half epsilon naught sigma square by epsilon naught square into A into D. Sigma square by 2 epsilon naught A into D is called pressure. Energy density, energy. So energy per unit volume gives what? Pressure only. Sigma square by 2 epsilon naught is also what? Or sigma square by 2 epsilon naught is also pressure. Now you tell me, energy per unit volume gives pressure. Energy per unit volume is pressure. Pressure into area is called what? Pressure into area is called what? Force. The force will be called force is equal to sigma square by 2 epsilon naught into area. The force between the two plates will be sigma square by 2 epsilon naught into area. Now see here, but again u is equal to what? Sigma square into A, but sigma is what? Q by, sigma is equal to Q by A. Q square by A square 2 epsilon naught A into D. So one A will cancel. So Q square, U is equal to what? Q square by 2 epsilon naught A by D. You bring D downward direction. So definitely this is Q square by 2C. That's what I am telling you. But Q square by 2C or half CV square or half QV, energy stored inside the capacitor when electric field lines are existing. This energy stored. Getting? Now energy stored inside the capacitor is, we can use these three formulas. Now, work done, initial energy plus work done by the external forces must be equal to final energy plus heat evaluated. Now, this is very, very important. Work done by external forces means plus work done by the battery also. Now, work done by the battery plus initial energy plus work done by external force must be final energy and heat coming out of the system. Now, I am asking you, capacitor is initially uncharged, means no charge, no energy. So, when we are connected through a battery, so how much energy is wasting as a heat? So, potential difference is V. When we close the switch, capacitance is C, but distance, but half CV square or QV by 2 or Q square by 2C. Now, capacitance but when we are getting positive terminal, electric field will be like this. Electric field will be existing inside. That energy, initial energy is 0. But finally charge Q is coming, minus Q is coming. How much charge is flown through the battery? Initially charge upon this one is 0, but positive charge is moving. What does the battery is? Q into V. So, but there is external forces. Now, Q into V plus 0, initial energy is 0, but final energy is what? Half QV plus heat. Now, heat must be equal to what? Half QV. ఎంతైతే ఎనర్జీ స్టోర్ అవుతుందో అంతే ఎనర్జీ హీట్ కింద డిసిపేట్ అయిపోతుంది. సో బట్ బై యూజింగ్ దిస్ యూ కెన్ యూజ్ వర్క్ డన్ ఎక్స్టర్నల్ ఫోర్స్ ఆర్ ఎగ్జిస్టింగ్ ఆర్ నాట్. ఇఫ్ ఈజ్ నాట్ ఎగ్జిస్టింగ్ కీప్ 0. ఇనిషియల్ ఎనర్జీ ప్లస్ వర్క్ డన్ ఆఫ్ ద బ్యాటరీ ప్లస్ వర్క్ డన్ ఆఫ్ ద ఎక్స్టర్నల్ ఫోర్సెస్ మస్ట్ బి ఫైనల్ ఎనర్జీ ప్లస్ హీట్ ఎవాల్యుయేటెడ్. గెటింగ్? బట్ దిస్ ఫార్ములా ఇస్ వెరీ ఇంపార్టెంట్. బట్ మనం ముందుకెళ్ళేటప్పుడు దిస్ ఫార్ములానే మనం వాడతాం అండి. ఇనిషియల్ ఎనర్జీ, వర్క్ డన్ ఆఫ్ ద బ్యాటరీ, but if positive charge is moving from negative to positive, work done on the battery is positive. Positive charge is moving from positive terminal to negative terminal, work done on the battery is negative. Keep this one. Now coming to current electricity. Means current electricity, you take conductor means EQ potential surface, but in electrostatic equilibrium. Now when we apply some potential difference, the conductor is not inside, electric field is existing. Why? Because we are applying some driving forces. Electric potential is applying. So definitely electric field will exist. So that electric field, electrons are moving against electric field directions. This electric field is not electrostatic field because of additional external sources we are getting, but it is not in equilibrium. But if conductor is in electrostatic equilibrium, net field inside is zero, but it is not in equilibrium, but we apply some forces. So current is established. Current is what? Current is equal to rate of change of charge flown, dq by dt. Q is equal to what? Plus or minus Ne, where N is what? Number of electrons per unit volume. Where N is number of electrons per unit volume. Q is equal to plus or minus Ne. But first to charge is quantized. Q is equal to plus or minus Ne. Here N is number of charge carriers per unit volume. Suppose you take any conductor, on an average, per unit volume, 10 power of 28 atoms are existing. 10 power of 28 per meter cube, centimeter cube. Now, Q is equal to Ne. So N is number of electrons per unit volume. But you consider Q is equal, I is equal to, Q is equal to what? Ne. But the electric charge is constant. Q is equal to what? Ne. So per unit volume. Suppose length of the conductor is A, length of the conductor is L, area of conductor is A, but volume is what? Into A into L, d by dt of A into L. So I is equal to dq by dt. N is constant, E is constant, d by dt of volume of the conductor. So N, E, A, dl by dt is called drift velocity. So this is very important statement. So I is equal to dq by dt, but N is number of charge carriers per unit volume, but volume of the conductor is how much? Area into length. So d by dt of area into length, if it is area is constant, length. So electrons are moving along the length, definitely I is equal to NEA VD. This is very important. So this is called drift velocity. Drift velocity. I by A is called current density. I by A is called current density. So J is equal to NEVD. So NEVD. Current density is a vector. So Ne times drift velocity of the electrons. Compulsory questions ఇట్లాంటి వాటి మీద ఉంటాయి మీకు అది డ్రిఫ్ట్ వెలాసిటీ వస్తుంది కంపల్సరీ కాన్సెప్ట్స్ కరెంట్ ఇట్లా ఏముంటాయి ఆల్రెడీ కాన్సెప్చువల్లీ సో I by A is equal to J is what? Current density. So but current passing per unit area only, but number of electrons into drift velocity. Now, but indirectly I am saying here, this is very important one. So I is equal to what? I is equal to Ne A bar dot Vd bar. This is what equation of continuity. మనం ఎక్కడ వాడాం? Just in fluids లో equation of continuity A bar dot Vd bar. So current is constant. If area decreases, drift velocity. So non-uniform conductor, you take non-uniform conductor like this. So non-uniform conductor, here area of cross section is less, drift velocity is more. So current will be same. Here current is same, here current is also same. Volume flow rate is same, electrons flow rate is same, but current is same. But drift velocity is more when area of cross section is less. Area of cross section is more, drift velocity is more. So always should think, but here velocity is less or more. Here V1, here V2. Here V1 and V2. V2 is greater than V1. Drift velocity, when cross section is less, drift velocity is more. Now you take I by A is equal to J NEVD. Next, just this is not Ohm's law. This is Vd is always drift velocity is always proportional to electric field. How? These electrons are moving. Drift velocity is nothing but what? Proportional to electric field. If electric field is zero, electrons will not move. If electric field is zero, there is no force on electrons. If electric field is non-zero, electrons experiencing force, it will move, gain some kinetic energy. So velocity. So drift velocity is proportional to E. That drift velocity is equal to what? Mu times E. That is called mobility. Mu is called mobility of free charge carriers. Write down this one. Mu Vd is equal to what? Mu times E. Substitute J is equal to what? J is equal to N A mu E bar. Na mu E bar. Drift velocity is always a mobility of charge carriers into electric field. drift velocity depends upon electric field. Electric field is 0, drift velocity is 0. If electric field is not 0, drift velocity is not 0. But this is called mobility. That mobility depends upon conductor, type of the conductor, type of the charge carriers. Suppose when we are taking semiconductors, holes are moving, conduction band and valence band. Valence band, holes are moving, conduction band, electrons are moving. So, but there is a, depends upon material where we are finding, okay. Mu d is proportional to E only. So, that is called J bar is equal to sigma times E bar. This is Ohm's law. This is a microscopic Ohm's law is J bar is equal to sigma times E bar. Sigma is called conductivity of the conductor. Electric conductivity. Sigma is equal to N E mu. That is called mobility. Number of charge carriers per unit volume, number of charge carriers and electron charges and type of charges. It's plus charge, keep plus sign. Minus charge, keep minus sign. So sigma is equal to N E mu. This is called mobility. That mobility depends upon only, mobility is what? Characteristic of charge carriers. So VD is proportional to electric field only. Just what I am saying, but you write down similarly. But see, but how we are getting, this is called microscopic Ohm's law. This is called what? Microscopic Ohm's law. Just I am telling you, V is equal to what? Just from this one, J is equal to sigma E, that is called Ohm's law. J is equal to sigma E, that is Ohm's law, microscopically. I by area of cross section, sigma is equal to sigma you keep, that E is equal to what? V by D or V by L, length of the conductor. Length of the conductor is, potential difference applied is V by L. Now I is equal to sigma A by L into V. Now V is equal to what? V is equal to L by sigma A into I. This is called a resistance of the conductor. So resistance is what? L by L by sigma A. So 1 by sigma is called resistivity. Resistivity. See this conductivity and resistivity. Substitute resistance of the conductor is equal to rho L by A. Resistance of the conductor is rho L by A. So this is simple. L 1 by sigma is called rho. Just we are keeping. So rho L by A is resistance of the conductor. If length of the conductor is what? L. Area of conductor is what? A. So resistivity is what? Rho. But resistance is what? Rho L by A. Resistivity is changing with respect to temperature, rho naught into 1 plus alpha delta theta. Whenever resistance is changing, the resistance also increases. R is equal to what? R naught into 1 plus alpha delta theta. When we increase the temperature, so definitely resistance will increase. Heat losses are more. So whenever resistance is increasing, just we are taking like this. Resistivity and conductivity. 1 by conductivity is equal to resistivity. Resistivity and conductivity is always equal to 1. I think you understand. But the drift velocity and conductor properties. Now resistance of the conductor is this only, rho L by A. Next coming to electric field. Inside, but J is equal to sigma E. This is called J is equal to sigma E. That is microscopic Ohm's law, and V is equal to I into R is called macroscopic Ohm's law. But you know this, V is equal to I into R. Microscopic Ohm's law, vector form is this only. J is equal to sigma E, and scalar form is what? V is equal to I into R. Clear? Two resistors are connected in series. What happens? R1 and R2 connected in series. Then what happens? Effective resistance becomes what? R1 plus R2. Two resistors are connected parallel. This is what? R net is equal to R1 plus R2. So when two resistors are connected in parallel, so definitely resistance R1 and R2. So R net will be called 1 by R net is equal to 1 by R1 plus 1 by R2. This you know. Okay, no need to explain this one. Two resistors are connected in series, effective resistance is R1 plus R2. If two resistors are connected parallel, 1 by R1 plus 1 by R2 is 1 by R effective. So this is a microscopic and macroscopic. This is a scalar form, this is vector form. Now you remember this one, okay? Next. Coming to. So batteries. Ideal battery and real battery. Ideal battery and a real battery. So what is the ideal battery? The internal resistance of the battery is 0. R is 0, that is ideal battery. But if internal resistance is not 0, R is not 0, that is what real battery. But ideal batteries are existing in theory only, but actually there is no ideal batteries. So, but EMF and potential difference, both how to calculate? EMF is what? EMF is electromotive force, work done by the battery to move any electron in a closed path, complete the circuit. That is called work done per unit charge is defined as EMF. That EMF is due to non-conservating forces, electromagnetic forces. So work done by the battery to move the electrons in open circuit are inside from negative terminal to positive terminal. So that is what work done the electrostatic force only. So always you remember EMF is work done per unit charge. Work done per unit charge. Now how to calculate potential difference? What is the difference between EMF is E and potential difference is V? A and B are given. How to write? But potential difference VA minus VB is equal to E. VA minus VB is equal to A. This is higher potential, this is lower potential, it is ideal battery. Internal resistance is 0. If internal resistance is not 0, so if internal resistance is not 0, how to write? But internal resistance here I can take, or here also I can take, at positive terminal also I can take. But it is what? The site is not defined here. Okay, current batteries. Resistance, where we have to keep? Towards negative terminal or towards positive terminal, or sometimes you can give like this also. Means the battery is having internal resistance, R is not 0. These are the just circuit, how to represent. This is also real battery, real battery, real battery. Internal resistance is not 0. But nothing is given to you, but internal resistance is 0 you take. So in theory, but you can get like this. Now how to get the potential difference between these two? A charging and discharging of the batteries. Now whenever current is coming from positive terminal of the battery, so that is discharging mode. Internal resistance is not 0. How to write potential difference between A and B? But potential of A, just VA. We are jumping along this direction, against. So we are jumping towards minus E. But we are moving against or along, minus plus IR is equal to VB. Kirchhoff laws, how to write? VA, we are jumping towards negative terminal minus E, but we are moving against current direction, minus R, plus IR. Current always moves from higher potential to lower potential. So definitely, but minus plus IR is equal to VB. VA minus VB is equal to what? VA minus VB is equal to E minus IR in discharging mode. In discharging mode, or towards negative terminal or away from the positive terminal, that is discharging mode. So VA minus VB is equal to E minus IR. Now coming to next one. But whenever current is flowing towards, and you consider, but ikkada kaadu, just AB, but that is what? Internal resistance I can keep anywhere, but A and B. Find out potential difference between them, VA, but current is flowing along this direction. Definitely current is coming out from the negative terminal or towards positive terminal, that is charging mode only. So VA, but we are moving along the current direction, potential drop will be there, minus IR, minus E is equal to VB. So VA minus VB is equal to what? VA minus VB is equal to E minus IR, E plus IR, sorry. So here VA minus VB is V minus IR, here VA minus VB is E plus IR. So in charging mode, potential difference is more than EMF. In discharging mode, potential difference is less than EMF. Charging of the batteries and discharging of the batteries we are getting like this. Next, when two batteries are connected parallel, E1, R1, E2, R2. How to write the potential difference between A and B? A and B. Just we can replace these two batteries with one single battery, but identical equal to this one battery and having some internal resistance. A and B, open circuit. It is open circuit. Now E1 by R1, that E is equal to E and R. E is equal to, write down, E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. So next, R effective is equal to, just we are taking, so many we can take, 1 by R is equal to 1 by R1 plus 1 by R2, because these two are parallel. Just we can make it open circuit, we can replace this. E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. Suppose if one of the bat is opposite direction, what happens? Minus and you keep. E1 minus E2, E1 by R1 minus E2 by R2. If positive terminals are connected, keep plus only. One positive and negative terminal is connected, so keep E1 by R1 minus E2 by R2. Take polarity. Now how to write this one? When we are connected like this, then R1, R2, R3, E1, E2, E3. Now, how to write? This is what, like this only. But R and E. How to calculate A and B? Potential difference, open circuit. So, E1, E2 are positive polarity connected. E1 by R1 plus E2 by R2 minus E3 by R3. E1 by R1 plus E2 by R2 minus E3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. But next this one, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Take like this, okay? Plus minus sign is important now. Now, one resistance is connected to ideal battery, but how to write equations? But EMF is E and current is flowing along this direction. How to write Kirchhoff laws? Just you start at this point, but you have to come back to the same point. So current is flowing along this direction. This is a driving battery. So current will deliver. Definitely electrons will move. So E minus IR is equal to 0. This is Kirchhoff laws. So when we move along current direction, so VA minus VB is what? VA minus VB is positive or negative? VA minus IR is equal to VB. So VA minus VB is equal to what? IR, positive. Just I am moving along this direction. If current is flowing along this direction, but resistance, if I am moving along this direction, so how to calculate A and B? Sometimes you may get like this. First point is this and second point. So just you are moving from this one, VB, but current you are moving against or parallel, VB plus IR is equal to VA. Now you tell me VA minus VB is what? VA minus VB is equal to IR only. So take this one. So IR. So VA minus VB, when we move along the current direction, potential drop will be there. Against potential gain will be there. See, we are getting VA minus VB is always IR only. Now when we take a capacitor, this is a positive terminal, the negative terminal. Just when we are moving, just along current is flowing along this direction, positive terminal only. So when we are moving along this direction, A and B, capacitance is C. How to write? This is plus Q minus Q. So how to write? VA. You are jumping towards negative terminal. Minus Q by C is equal to VB. You are jumping towards, you are moving along this direction. You are jumping towards negative terminal. So minus Q by C you have to keep. Now, if same question I am asking you, this is the first question. This is what? Plus Q and minus Q. And we are moving from A to B. Yes, sir, B to A. So you are jumping along this direction. Current is flowing along this direction. So VB, but which direction you are jumping? You are jumping towards positive terminal. So plus Q by C is equal to what? VA. So now tell me VA minus VB is what? VA minus VB is Q by C. But here also VA minus VB is Q by C. How we are writing Kirchhoff laws? Very important. Exams lo meeku vachetondi ee actually. So how to write but Kirchhoff laws while we are moving along the current direction or across resistance or capacitance? You can get like this. Now if you take inductor, but we have these three only, but current is flowing along this direction. So I, L. So A and B, definitely VA, but when we move along this direction, minus L into dI by dt. So is equal to VB. So when we are moving along this direction. So always inductor, capacitor and resistance all are passive elements. Passive means it can consume energy or which can store energy. Resistance always consumes energy but gives energy in the form of heat. But capacitor always stores energy in the form of electric fields. How much energy? Half epsilon naught E square into V. But inductor is always stores energy in the form of magnetic field, half Li square. Half Li square we are getting. So capacitor and inductor both can store energy, but resistance always dissipates energy. So always you remember this one, okay? So when we move along the current direction, minus L into dI by dt. So against also you can get like this. Now coming to galvanometer. Effective resistance you are able to find out. Galvanometer. Galvanometer is what? Simply moving coil galvanometer. In magnetics you can teach. But some current will be flowing in this one. Whenever current is flowing, galvanometer current is Ig and the resistance of this one is Rg. Galvanometer Rg. Potential of across this is what? Vg is equal to Ig into Rg. Now this galvanometer always gives the presence of the current, always measures presence of the current. But how to calculate the current in the circuit? So that current can use by galvanometer. So how ammeter? Ammeter is what? The galvanometer connected to one shunt resistance or shunt resistance parallel to this one. So galvanometer maximum current is Ig only, resistance is Rg. Now when current is flowing in this direction, so but current is flowing along this direction, Ig, but remaining current I minus Ig is flowing through this. Ig into Rg is equal to potential drop across galvanometer and resistance, because both are parallel, same. Potential is the same parallel. So I minus Ig into Rs. So you can write Ig into Rg plus Rs is equal to I into Rs. Now Ig is what? Just you can find Rs, Ig also. I is equal to what? I is equal to R1 plus Rg by Rs into Ig. So Ig by I by Ig you can calculate. So current, see, but 5 amperes coming, passing through this is 1 ampere. So we can give that deflection. It can give the deflection. So always you remember, sensitivity is always theta by I. When theta by I is current sensitivity. So I by theta is called quality. This is called sensitivity. Sensitivity, and I by theta is called quality. Quality current means I by theta. So you remember this one. Now I is equal to what? 1 plus Rg by Rs into Ig. So if I want to increase the range of the ammeter, you have to increase the shunt resistance. So how much? I is increasing. For I1, R1. For I1 is 1 plus Rg by R1 into Ig. Ig remains same. I2, if I want to increase, 1 plus Rg by R2 Ig. We can find how much. From I1 to I2, if I want to increase, so which one I have to change? The shunt resistance. How much additional shunt resistance you have to connect it. So this is what. Always we can find the ranges also, to change the ranges also. Next, voltmeter. Ideal ammeter resistance will be 0. Ideal ammeter resistance will be 0. Take voltmeter. Voltmeter we are showing like this. Ammeter we are showing like this. How we are going to connect ammeter? Just break the circuit and connect. Break the circuit and connect. Suppose how to connect ammeter? Suppose initially we are having like this. But to measure the current, how to connect? Break the circuit here and connect here. So like this. Like this. So break the circuit and connect. Series combination. Now voltmeter is what? Just voltmeter always measures the voltage drop across any elements. So we have to connect a high resistance in series to the galvanometer. High resistance. But shunt resistance is small, but high resistance must be in series, but Rg must be there. But already you know, potential drop across this is V is equal to what? Ig into Rg. So Ig only flowing to this. So we have potential drop across these two V is equal to Ig into RH plus Rg. V is equal to what? I by, but Ig, but already we are getting V is equal to Ig into RH. This is what? Plus V on galvanometer. So V minus Vg by Ig gives resistance connected in series. If I want to change 100 volts to 1000 volts range, just V by, just you consider V by Ig minus Vg by Ig is what? Vg by Ig is Rg is equal to RH. So enta shunt anta enta series resistance connect cheyalanedi just we are getting. If I want to increase from 100 to 1000, first initially you connect 100, you will get one value. When we are getting 1000, but these two values are fixed, we are getting. Suppose Ig is 1 milliampere, Ig is equal to 1 milliampere, Rg is equal to 1 ohm. So to increase to, so this is how much now? So this is what? 1 millivolt. This is what Ig into Rg, 1 millivolt. So increase to 100 volts. So keep 100 by Ig is how much? 10 power minus 3 amperes minus 1 ohm is equal to what? How much series resistance you have to connect to galvanometer? So 10,000. So sorry, 1 lakh. 1 lakh minus 1, 9 lakh. This resistance you have to connect. Are getting? When we want to connect, so 100 volt, 100 volt range I want. So 100 by Ig minus Rg. So how much a series resistance you have to connect? You can calculate by this only. Next. Getting what? What happened? F1 లో ఉంది అది. F1 లో ఉంది. F1 లో ఉంటే రాదు యాక్చువల్గా. నెక్స్ట్ galvanometer very important మీకు అది. Galvanometer but voltmeter. Voltmeter always connected parallel. Voltmeter connected, no need to break the circuit. You have to connect parallel to that. Next connect. Now meter bridge or Wheatstone bridge. Wheatstone bridge what? Wheatstone bridge is what we are taking. 4 resistors are connected like this. Wheatstone bridge balance. This is very, very important. The many of the circuits we are getting Ig. This is galvanometer and but we are connecting one source here. When we close, this is Rx, R1, R2, R3, R4 is Rx only. Now, when we are changing the resistances at a particular VA and B, VA minus VB is 0, galvanometer current is 0. VA is equal to VB, that is called a balanced Wheatstone bridge. So then R1 by R2 is equal to what? R1 by R2 is equal to R3 by R4. Now R4 is equal to what? R4 is equal to R2 by R1 into R3. So this a major role is what? But finding unknown resistance. When galvanometer current is 0, these 3 are known resistance. We can find unknown resistance connecting between these 3 also. So this is called, whenever potential of A and B points are 0, galvanometer current is 0. That is called balanced Wheatstone bridge. At that time, we are able to find out unknown resistance. Then R1 by R2 is equal to R3 by R4. That is called Wheatstone bridge balance. But always you remember, but this sensitivity is depends upon the sensitivity of just Wheatstone bridge is balanced depending upon R2 resistance only. Sensitivity of Wheatstone bridge is depends upon R2 only, not on all others, only R2, because R2 by R1 into R3. So remember, this is called balanced Wheatstone bridge. Now when we replace battery between A and B and galvanometer between C and D, nothing will change. When we replace battery to galvanometer and galvanometer to battery, nothing will change. We can connect here battery and between C and D also can take, but nothing will be changing. As is, result will be as it is. Questions adugutan mikadi. But when we replace galvanometer and first circuit is this, second circuit is what we are replacing. What will change? Nothing will change. As it is, you will get everything. Now coming to meter bridge. Meter bridge is what? 1 meter wide connected between points A and B, one frame, one unknown resistance is connected and just known resistances. So we are getting one balance jockey and galvanometer. So resistance per unit length of this 1 meter wire, 100 centimeters only, 100 centimeters. So at a particular point we are getting X, balancing length is 0, means R1, Rx, unknown resistance. But resistance per unit length you know, but this resistance is R3, R4. So resistance per unit length is lambda, but resistance of this X length is what? Lambda X. So remaining length is what? 100 minus X into lambda. Resistance of this part is 100 minus X into lambda. resistance of this length is Rx. So when the galvanometer current is 0, this is like a balanced Wheatstone bridge. R1 by R2 is equal to R3 by R4. R1 by Rx is equal to lambda x by 100 minus x, x by 100 minus x. So we are able to get balancing length also. So we are keeping unknown resistance here. We have to keep left gap only, not right gap, but unknown resistance we have to keep. But anyhow, but R1 by R unknown will be x by 100 minus x. So resistance, but we can find the unknown resistance by using this meter bridge. Unknown resistance value we are finding by using meter bridge. So if you know x length, we are able to get Rx value. So Wheatstone bridge balance on always, this is also. You remember. So when Rx is increasing, so this value is decreasing. This value is decreasing means this is nothing but what? 1 by 100 by x minus 1. So this value is decreasing means this value is increasing. This value is increasing means this value is decreasing. This value is decreasing, x is increasing. So values etla vaste chuskondi. Increasing and x to be decreasing. Idi increase avutunte em avutundi? This value is going to towards leftward direction avutundi. If this is decreasing, this point is moving towards rightward direction. Okasari adutadu beta. So ikkada resistance pettama, ikkada resistance, unknown resistance. Unknown resistance is more. Suppose you are getting balancing point less than 50. Answers చూసుకోండి ఒకసారి మీకు క్లియర్ గుర్తుపెట్టుకోండి ఆన్సర్స్ ఎట్లా ఉంటాయి. సో దిస్ ఇస్ 5 ohms. This unknown resistance. Balancing on this 49. Balancing on this 49. The 49 is less than 50. So this should be more than 5 ohms. You keep the answer. This is 5 ohms. So balance on this 49. This is 51. So definitely this resistance should be more than this. So this is 5.1 something like that. Calculation చేసినప్పుడు అలా ఉంటే ఆప్షన్స్ అలా ఉంటే చెక్ చేసుకోండి. Now next potentiometer. Potentiometer is very important now. This is a potentiometer wire length will be 10 meters. 10 meters practically. This is a primary circuit. We are connecting primary battery. Rheostat. Rheostat can help to change the potential gradient across the wire A and B. This is a primary circuit. The length of the wire is L. So first you find out potential drop across A and B. VAB you find out. This is your major part is what? Always whenever potentiometer is given, you find out first potential drop across AB and potential gradient, that is alpha. So from primary source E1 is applied. So when rheostat just resistance can be varying from 0 to 5,000 ohms. Now the resistance of this is what? Given small r. But anyhow, we can find the potential drop across AB. First you find out potential drop across AB. Then divide with the length. That is called a potential gradient. Now, you bring one unknown EMF cell and having some internal resistance connected to one external resistance now through one switch. Galvanometer and jockey. First you keep, primary circuit is what? Precaution is also very important. First you touch jockey at A. In galvanometer deflection will be rightward or leftward, you will get. Now this jockey is touch immediately at point B. The deflection is opposite, definitely you will get null point. If deflection is the same direction, you will not get the null point. So what is the problem? So this voltage is more than the primary voltage. E0 is more than the primary voltage, or otherwise you are connected wrong polarity. Negative terminal of the battery connected to positive terminal. You change. So these two are important. Precautions are very important. Now everything is connected properly. Now close switch S1. Switch S1 is closed. Now we are getting some balancing length at X1. So potential drop across per unit length is what? Alpha. Alpha is what? VAB by L. Now potential difference at X1 is what now? So alpha into X. Potential drop between this is what? Whenever galvanometer current is 0, AC is what? V. So then current passing through this is also 0 is equal to E1. So whenever galvanometer S2 is open and S1 is closed, galvanometer current is 0. Whenever current passing through this is 0 and potential drop across A and C and internal EMF will be remain same. Alpha into X means E0 is equal to VAB by L into X1. Now that is what we are able to find out EMF of the unknown cell. Now to find the internal resistance of the unknown cell, just close S2 also now. Close S2, then close S2, but the balance length we are getting at X2. So now, whenever it is closing, the galvanometer current is 0, that length is X2. So that is what? Alpha into X2 must be is equal to, this current is what? Current is generating, but current is flowing in this direction. So that current is nothing but what? I is equal to E by R plus capital R, just small r and capital R. Now potential difference across this one and across these 2 points, will be remain same. I into R is equal to E minus IR. It is discharging mode only at the time. E minus IR, E naught minus IR. Now you take alpha into X2 is equal to VAB by L. VAB by L is equal to, VAB by L into X2 is equal to E naught is what? E naught is VAB by L into X1 minus I into R. So you bring this side. We can get X2 minus X1 VAB by L is equal to I is what? E naught. E naught is what? EAB by L only. E naught by R plus small r into capital R. Small r. So you keep, just you can take this one also. Alpha is what? VAB by L into X2 is equal to VAB by L into X1 by R plus R. R plus R into capital R. VAB by L will cancel. X2 by X1. X2 by X1 by X2 is equal to 1 plus small r by capital R. So R by capital R is equal to X1 by X2 minus 1. So R is equal to what? X1 by X2 minus 1 into R. So we can find internal resistance by using. This is what? X1 when we are finding initial length, but X2 when we are closing the switch S2 also. So we can find the internal resistance. Just I am giving you, but a potentiometer wire is using for to compare the unknown EMF cells voltages and to find the unknown EMF of the cells and to find the internal resistance of the unknown EMF cell. So to increase the sensitivity of the potentiometer wire, this is very important. Now when we are keeping just nearly 10.01, just I can keep at 9.9, but exactly we cannot keep. Human errors are present. But to minimize the human errors, so sensitivity should be increased. So instead of keeping at 10.01, I can keep at 9.99 also. So when we are keeping at 9.99 instead of 10.01, so the potential variation should not be varying much. So that is called sensitivity. So to increase the sensitivity, only one thing, only increasing the length of the potentiometer wire only. To increase the potentiometer wire sensitivity, only increase the length of the potentiometer wire. Don't increase E1. Don't increase the resistance of the rheostat. But only the one case, the only potentiometer wire sensitivity increasing by increasing its length only. Length only. Okay, that's the potentiometer wire. Coming to RC circuits, charging and discharging of the capacitors. Capacitor, when it is charging, capacitor and R is E, switch is closed. So charge will be increasing to Q naught maximum value into 1 minus e power minus t by tau. Tau is called what? R into C. Time constant is called R into C. So capacitance is C, R. When we close the switch, capacitor is charging. So at t is equal to 0, capacitor charge is 0. At t tends to infinity, Q naught. That is called Q maximum. That is what Q naught is equal to what? C into E. C into E. So current is also decreasing I naught into e power minus t by tau. I naught is equal to E naught by R e power minus t by tau. Tau is equal to what? R into C. But when we close the switch, initially current is maximum. The potential drop across any potential is equal to Q by C. So Q is 0 initially, potential drop is 0. But initially, capacitor behaves like a conducting wire. Initially, no charge, capacitor behaves like a conducting wire. Current will be maximum at t is equal to 0, that is E naught by R. So at t tends to infinity, current becomes 0, potential drop across resistance becomes 0, and potential drop across capacitance becomes E. So potential drop across resistance is also changing, E to e power minus t by tau. Potential drop across capacitance is always E naught into 1 minus e power minus t by tau. This is a very important moment. So potential drop and current and the charges inside the circuit, we are getting like this. So charge is Q naught into e power minus t by tau. Tau is equal to R net into C net. So Vc is equal to potential drop across capacitance also changing from 0 to E naught into 1 minus e power minus t by tau. So across resistance, across just in the circuit, we are getting current like this. Now capacitor is discharging. If discharging mode, if capacitor is discharging through one resistor, so in discharging mode, then there is no voltage sources. So capacitor is a fully charged, but current will send along this direction. The current is always I is equal to what? I naught into e power minus t by tau. The current initially at t is equal to 0, maximum current is flowing, but after a long time, current becomes 0. Charge is also decreasing to Q naught into e power minus t by tau. So voltage across the capacitor becomes what? V is equal to what? Vc into e power minus t by tau. And resistance VR is equal to minus V naught into e power minus t by tau. When we are adding always, by using Kirchhoff laws, there is no external source, potential drop will be 0. VR plus Vc is always 0. VR plus Vc is always 0. Like this. Discharging mode, charge is like this. Now coming to discharging mode, you remember this one. Next coming to magnetics. Magnetics means whenever the moving charge produces magnetic field as well as electric field. So when charge is at rest, only electric field will present. Whenever charge is in motion, definitely it will produce magnetic field also. Just bitsat law in magnetics, bitsat law is what? Whenever current carrying conductor is given, but I is flowing. So DL element you consider at a point R. So magnetic field we can find, that is dB is equal to what? Mu naught by 4 pi. Mu naught by 4 pi I dl bar cross r cap by r square. So r cap by r square. That is what vector form. The magnetic field is always by using right hand rule, but in the current carrying direction keep r bar cross b bar. Ideal bar cross r cap means ideal bar along this direction r cap. So thumb gives into the plane, magnetic field into the plane, we are showing like this. So magnetic field is a vector. When we are, current is flowing upward direction, but left side, right side of this conductor, magnetic field into the plane. When we take a left side, definitely coming out, that is nothing but what? Mu naught by 4 pi, ideal bar cross r bar by r square only. That is called bitsat law. With the help of bitsat law, we can find magnetic field of any configuration. So magnetic field due to current carrying wire is like this. Now ideal bar cross r cap by r square. Now pure vector form dB bar is equal to, but I mu naught by 4 pi. This is what? Permeability of free space. Permeability of free space. Mu naught value is always 4 pi into 10 power minus 7 units. We can get everything. So magnetic field we are representing in Tesla. We can find the dimension formula of mu naught also. Mu naught dimension formula to write. Mu naught epsilon naught is equal to what? Mu naught epsilon naught is equal to 1 by c square velocity of light. Always you remember. Mu into epsilon is equal to mu into epsilon is equal to 1 by c square. C naught square is different, c square is different. C is what? Velocity of light in a particular medium of permeability mu. So c naught square is what? Velocity of light in particular medium of free space. So we can find the dimension formula. Epsilon naught and mu naught. Now this value remember. So whenever current carrying wire is given according to bitsat law, we are getting mu naught by 4 pi into ideal bar plus r cap by r square. Now whenever you are finding magnetic field due to charged conducting wire, charged wire, how to calculate charged wire? Charge, just charge is moving with velocity v. How to calculate? So just I is equal to what? I is equal to dq by dt. So magnetic field at any point, if dB is equal to according to bitsat law, mu naught by 4 pi I dl bar cross r cap by r square. Already చెప్పాను ఇప్పుడు. So dq is equal to what? I is equal to dq by dt. So q is equal to what? Just dq by dt we are writing. Q is equal to I into dt. I into dt. రాయండి ఒకసారి I బదులు dq by dt రాయండి. ఎంత అవుతున్నప్పుడు నీకు q by dl bar by dt cross r cap by r square mu naught by 4 pi. So dl bar by dt is what? V bar. So whenever charge is in motion, the magnetic field produced by the charge at any point will be, so the same format, mu naught by 4 pi q into V bar cross r cap. V bar cross r cap by r square. So moving charge produces magnetic field as well as electric field. So that the electric field is always is equal to 1 by 4 pi epsilon naught q by r square along radial direction. Just what is the relation? Just when we take integration, we are getting B only, B like this. So this is what magnetic field created by the moving charge. This is also electric field created by the moving charge. The self-creating magnetic field relation is B bar is equal to mu naught by 4 pi q into V bar cross. B bar is what? R cap is equal to E bar into 4 pi epsilon naught R square by Q by R square. R square will cancel, Q will cancel, so 4 pi will cancel. So B bar is equal to mu naught epsilon naught is 1 by C square into V bar cross E bar. So this is very important relation. So moving charge can create electric field as well as magnetic field. The relation between them is B bar is equal to 1 by C square into V bar cross E bar. V bar cross E bar. This is not external magnetic field. This is not external electric field. The self just created magnetic field and electric field relation is what? One charge is moving to velocity of speed V and velocity of light is C. That is the relation. C naught and in vacuum. Okay? Now, so force, whenever we are projecting any charge, but bitsat law is that, Ampere's law is what? Ampere's law is very important. Now whenever highly symmetrical bodies, current carrying along this direction, Ampere's law is B bar dot dl bar is equal to mu naught into I enclosed. See? But I enclosed. So whenever current is flowing along this direction, you take one Amperian loop of radius r. Magnetic field at this point is what? Just you curl, just in the direction of the curling. Magnetic field is along the curling direction only. Total length is what? 2 pi r. B into 2 pi r is equal to mu naught into I enclosed is I only. Current carrying wise. So B is equal to what? Mu naught I by 2 pi r. So this is what? The infinite current carrying wire is given to you. At any point r, the magnetic field is mu naught I by 2 pi r. So when we find bitsat law, according to bitsat law, magnetic field at any point will be mu naught by 4 pi into I dl bar cross r bar by r cube. But from this one we are getting, so sin alpha plus sin beta. Magnetic field due to finite current carrying wire, this is alpha and this is beta. So definitely mu naught by 4 pi r, mu naught by 4 pi r into sin alpha plus sin beta into the plane only. The magnetic field at any point will be mu naught by 4 pi r into sin alpha plus sin beta. So if alpha is equal to beta, then mu naught I by 2 pi r sin alpha. So alpha and beta goes to infinite, means infinite current carrying wire. Due to infinite current carrying wire, but sin alpha and sin beta goes to 1, 1, 2, mu naught I by 2 pi r. So this is what? Ampere's loop law is a very easy way to find the magnetic field due to current carrying wire. The highly symmetrical bodies we are using this formula. Otherwise, it is not applicable. Bitsat law is always you can use. This is vector form. Now magnetic field at any point will be winding the direction by curling the fingers only. So into the plane. So some currents are going, suppose I am taking like this. So current I2 is along this direction, I1 is along this direction. So current is I3 is along this direction. How to write? But you are curling along this direction. Now how to write? but going away I2, coming towards negative. I mean, I2, I1 are going away. I3 is into the plane. So now you take, how to write? So outward currents are positive, inward currents are negative. So, but flux is always, we are finding like that only. But outward is always positive, inward is always negative. So here how to write? B bar dot dl bar is equal to B bar dot dl bar is equal to mu naught into I1 plus I2 minus I3. Here minus I3. So Amperian loop law, this is not exactly correct, but now in magnetostatics, means magnetic field is constant, but constant current carrying wires are given to you. These conduction currents we are using, this Amperian loop law. Now coming to, so whenever just one current carrying conductor is given to you, but placed in external magnetic field, what happens? Whenever we are placing in magnetic field, external magnetic field, current carrying wire is of length L, so it will experience a force. That force is always, that force on current carrying wire is I dl bar cross B bar. The force when we keep any current carrying wire in the external magnetic field, definitely it will experience a force. That force is always I dl bar cross B bar. If this is open wire, but current is I, but length is L, the force is what? I dl bar cross B bar. Now it is a closed, this is what a dl bar, uniform magnetic field. A force is always defined as I dl bar integral I dl bar cross B bar. The magnetic field is constant, dl bar cross B bar. Now when we take a closed loop, any loop closed, current is flowing, but kept in magnetic field, how much force you will be experiencing? So dl bar is 0. dl bar is 0. Any closed loop is keeping in external magnetic field, the force acting on that must be always 0. Forcing acting on that will be always 0. Why? But the displacement is what? Starting point and ending point both are same. So displacement is 0. We always remember ideal bar cross B bar is what? Displacement function. So now you tell me, but when we are keeping like this, wire is keeping like this. So this length is L, ఇది B, H, lengths are like this. Magnetic field into the plane. So what is the force acting on this wire? So force acting on this wire, magnetic field is given downward direction, current is I. So current is flowing like V shape. Now this length is B, this length is H, this length is what? Distance between the 2 points is what? End points are L. So how much force you will experience on this one? So simply displacement is what? The shortest distance between the starting and initial final points is L. So current of direction is what? Along this direction. So I dl bar cross B bar, force must be along this direction. So that force is equal to what? That force is equal to I L B only. Force on this wire is what? ILB. ILB only. Displacement. So I am taking you, this is what? Quarter circular part is given, quarter circle. Current is flowing like this. Force acting upon this one is what now? So magnetic field is given into the plane. But force acting upon this one is just you draw. Displacement of the vector is along this direction. So how much is displacement? Root 2r. So r is radius, root 2r. The force must be ideal bar cross B bar. In which direction? In this direction. Force must be perpendicular to length and magnetic field. That force is equal to what? I root 2 and B. So questions are data solve try cheyandi. The force acting on any open conductor is not 0. That is what I dl bar cross B bar. Force on any closed conductor kept in uniform magnetic field, definitely it will be 0. That is what displacement vector is 0. So definitely magnetic field is not 0, current is not 0, but the displacement is 0. So force acting on any closed conductor kept in external magnetic field is always 0. Next. So force on moving charge in external magnetic field. Suppose the magnetic field into the plane existing. So when we are projecting with speed v, so what happens? Whenever that electron, that anyhow charge, positive charge is moving, but this will experience a force. But we have two types of forces. One is electrostatic forces, that is Q into E. Next one is called magnetic forces. The magnetic force on moving charge particle is already there is a force on charged conductor is what? Force is equal to what? I dl bar cross B bar. Yes? Now force on moving charge is what? I is equal to Q by T. Q dl bar by dt cross B bar. dl bar by dt is what? V. Q into V bar cross B bar. The force on any charge, force acting on charge when it is moving in the external magnetic field is Q into V bar cross B bar. So definitely you tell me, but Q is what? Force is perpendicular to V bar and B bar as well as vector product. So definitely that force is perpendicular to magnetic field, and the force is acting along this direction, V bar cross B bar upward direction. The particle will deflect along this direction. So it will try to move in circular path. So just before I explain, the magnetic force will changes the direction of the charged particle, not the vector magnitude. So only changes the direction, not magnitude. The electric field always changes the magnitude, but not the direction. So whenever we are projecting only magnetic field, it will experience a force, that is Q into V bar cross B bar. That force is always perpendicular to V bar and B bar also. That is R. Always remember V, B, R are always perpendicular in this case. Now, how to calculate this radius of curvature? But always changes. How to calculate radius of curvature? That magnetic force is equal to Q into VB sin theta. But if angle is not 90, Q into VB sin theta is equal to mv square by R. If theta is 90, sin 90 goes to 1, V cancels. So that is providing the centripetal force. Centripetal force always changes the direction, not magnitude. That centripetal force is mv square by R. That is nothing but what? Balancing with qv sin theta, qvb sin theta. But theta is equal to what? 90 you consider. Now angle between magnetic field and velocity vector is 90. qb is equal to mv by R. R is equal to radius of curvature is equal to mv by qb. So this is very important formula. Whenever we are projecting one charged particle in external magnetic field perpendicular to the magnetic field, so definitely R is equal to mv by qb. That charged particle try to move in a circular path of radius R. R is equal to mv by qb. So R is equal to momentum by, but velocity at any point will be what? Along this direction. The direction is changing, magnitude remains same. So this particle is moving on uniform circle, radius circle with the constant magnitude of momentum by qb. So or otherwise v by qb by m. qb by m is called omega. Omega is the angular velocity of any charged particle projected in external magnetic field is omega. That omega is only qb by m. Q is a magnitude of the charge, B is the magnitude of magnetic field, and m is what? Mass of the charged particle. So this is called angular frequency, and the time period is nothing but 2 pi by omega. Time period or omega is independent of velocity of projection. So you project with the velocity of light, you project with the velocity of plane, you project the velocity of car, you project the velocity of man. Man velocity maximum is what? Very small. So or dogs like this, Chita. Now, but it is what? Angular frequency or time period are independent of velocity of projection. Only depends upon Q, B and M. This is always fixed. If charge is magnitude is fixed, magnetic field is fixed, M is fixed, omega is fixed. Time period is what? 2 pi m by qb. Now always you can find R is equal to V is equal to R omega. Ee formula meeku gurtunda? V is equal to R omega. Circular motion law. V is equal to R omega concept we are using. Pure rolling concept. V is equal to R omega. Like that only. Whenever we are projecting any charged particle into the magnetic field, perpendicular to the magnetic field, definitely try to move in a circular path with a uniform magnitude, uniform speed, and only changes the magnetic, only magnetic force changes the direction only. So that magnetic force is always centripetal force, that is QVB is equal to mv square by R. So this is our radius of curvature. Now coming to magnetic link only. Coming to magnetic field is just finding magnetic forces and everything. Now when we are two electric field and magnetic field both are there, magnetic field and electric field both are there, the making angle theta. But when we are releasing one charged particle, what happens to this? Charge electric field always try to increase the momentum. So changes the momentum by changing the magnitude only. But magnetic field also changing the momentum by changing the direction only. The momentum is nothing but what? M into V. The mass both cannot change. So only the magnetic velocity can change, but direction of the velocity can change. The magnetic field changes the momentum, and the electric field changes the momentum. The momentum is a vector quantity. The electric field always changes the momentum magnitude only, but the magnetic field always try to changes the direction of the momentum only. If now when we are keeping, definitely it is experiencing force along the direction, velocity will be increasing. One component is along parallel, one component perpendicular to this. So always a radius of curvature we are finding r is equal to m into v perpendicular component of velocity to the magnetic field by q into b. This is very important one. So r is equal to v perpendicular component of velocity by omega. So in just to charged particle, suppose when we are proving like this, so magnetic field is this, velocity is given as theta, v cos theta, v sin theta. So this will try to move, the force will be what? Along this direction. Magnetic field is what? Velocity v bar cross b bar. So magnetic field is like this, it will move. So definitely it is moving like helical path. So this is called pitch. In one complete cycle, along the magnetic field direction, distance moved to the charged particle is called pitch. Pitch is equal to v cos theta into time period. This is very important. Okay. Along the magnetic field direction, distance covered in one complete rotation is called pitch. That is called helical motion pitch. Coming to electromagnetic induction. EMI concept is what? Faraday's law is what? So whenever there is a change in magnetic field, whenever flux is changing, flux is defined as what? B bar dot A bar. So B A cos theta. So rate of change of flux gives what? Rate of change of flux is nothing but always EMF is induced. This is called Faraday's law. Minus sign is very important. Whenever flux is changing through a loop, always opposite change in flux. Here flux and in statics momentum both are same. So inertia property. Now minus d phi by dt is called EMF induced. Now you can consider, but here minus d phi by dt is called what? dB by dt into A cos theta, or minus dA by dt into B cos theta, or plus AB omega into sin theta d omega by dt. So these two components are called just all are motional EMF only, but motional EMF is this. This is called just, this is very very important. The minus sign is there actually, but three ways flux can change. Either magnetic field, but the area of the loop is constant. Magnetic field passing through, this is a function of time. Definitely the changing magnetic field, magnetic field produces change in induced EMF. Induced EMF is due to induced electric field. That induced electric field always try to move the charged particles when they are at rest. So this is what non-conservative. This is a induced electric field produce. This is what due to charge separation electrostatic field will produce. So here we are using the induced electric field. Here we are using static electric field. Evaru? Ma madam, నేను క్లాస్లో ఉన్నాను చెప్పు, మళ్ళీ చేస్తాను చెప్పు. వాళ్ళు బయలుదేరి రమ్మని చెప్పి, ఇక్కడ రమ్మని చెప్పండి. బయలుదేరి ఇక్కడ రమ్మని చెప్పండి. Now, so EMF is equal to what? Minus d phi by dt. So here three factors are there, okay? But any factor, just magnetic field changing, definitely produces EMF. So area is changing, produces EMF. So omega is changing, rotating, just will produce the EMF. So that is what, but Faraday's law is very very important. But in Faraday's law we are finding three ways change in flux. The change in flux always produces EMF. That EMF by resistance gives what? Current. That is induced current. So that EMF is what? Minus d phi by dt minus d phi by dt by r. See? But from this one, I into dt is called what? I into dt is called minus d phi by r. So when we take this one, how much a charge will pass through this one? Delta Q. Delta Q is equal to what? Delta phi by R. This is very, very important statement actually. So, whenever current is, inducer current is flowing, how much a charge is flowing when flux is changing? If flux is changing delta pi, how much a charge will flow? By R. So, EMI by R is called what? Minus d phi by dt R. So, I into dt is called what? Charge flown. I is equal to dq by dt. So, I into dt is called delta q. How much a charge will flow through this? Minus n must be there. So, minus delta q by R. So, delta q is equal to minus delta phi by R. So, this is important statement. Now, take, but whenever flux is there, definitely you will get. But magnetic flux, magnetic field due to current carrying wire is what? Magnetic field due to current carrying wire at center is what? Say center. So, always you remember, but any arc length of wire is given, current carrying wire is I. So, definitely at the center magnetic field you can find B is equal to mu naught I by 4 pi R into theta. If closed loop you take, if closed loop theta is equal to 2 pi, substitute what you are getting? Mu naught I by 2R. Mu naught I by 2R. If semicircular wire is given, magnetic field is how much? Semicircular wire theta is what? Semicircular wire is theta is what? Pi. Closed wire 2 pi. But semicircular wire pi. Substitute pi here. Mu naught I by 4R. So, whenever we are getting magnetic field, you can find the magnetic field at the center of this. Where is R? Find current is flowing like this. Find magnetic field due to this configuration. How to calculate? So, due to this 0, due to this 0, but only semicircular wire. How much you are getting? Semicircular wire mu naught I by 4 pi R into pi. So, mu naught I by 4R. At center mu naught I by 4R. But direction is what? Just in the direction of current you curl, but thumb gives the direction, magnetic field is into the plane. So, mu naught I by 4R. So, always you remember direction of the magnetic field is very important. Now, coming to flux is always defined as what? Flux is equal to what? Flux is equal to B into A. Suppose if one loop is there, but magnetic field is, magnetic current is what? I. How much magnetic current will produce here? Mu naught I by 2R. At the center mu naught I by 2R. Just already we calculated. Theta is equal to what? 2 pi. Mu naught I by 2R. So, magnetic field at center is equal to mu naught I by 2R. Mu naught I by 2R. Now, if area of the loop is how much? If area of the loop is pi R square. So, magnetic field is what? Magnetic field mu naught I by 2R into A pi R square. So, flux, self flux is what? Self flux is mu naught pi R square by 2R. So, ఎంత అవుతుంది నీకు? Mu naught pi by 2 I. So, whenever loop current is flowing, if current is changing, if current is not a function of time, so magnetic flux is also changing. So, flux is, current is constant, flux is constant, EMF will not induce. The how much flux is passing through each and every loop. So, that is very important now. So, but when one loop is there, flux is what? B into A. N loops are there, flux is what? N into B A. Take solenoid. Solenoid is what? Solenoid is a continuous number of loops are producing now here like this. So, very, very tightly winded solenoid where radius is very small, area of cross section is very small, that is nothing but infinite solenoid only. Current is passing through that. Current is flowing in this direction. That is called self-inductance of the self-inductor, self-opposition. Now, but we can get like this. Flux is nothing but what? N into B into A. So, indirectly, flux is equal to what? L into I. Flux is equal to what? When we take inductor, L into I also. But chala concepts only, but we are having less time. But phi is equal to what? L into I. So, flux per current is nothing but what? Self-inductance. Flux per current is called what? Self-inductance. That self-inductance is a self-opposition when current is passing through this. Inductance is always opposite variation of current. So, flux is what? Flux is equal to, due to solenoid, magnetic field is mu naught N into I, where N is number of turns per unit length. Suppose N turns are there, length is L. So, what you are saying? B is equal to mu naught Ni. N is equal to Ni by L. L is the length of the solenoid. Say L. So mu naught Ni is magnetic field due to solenoid. Suppose flux due to solenoid is what? N loops are there. Flux is equal to N into B into A. Substitute N mu naught N square I by L into A. That is called flux. Flux due to solenoid is what? Mu naught N square I by L. Now you substitute just here L, here L. What happens? N by L is number of turns per unit length is what? Small n. Mu naught N square I into volume is equal to what? Flux. So flux per unit volume is flux per unit current is called, that is self-inductance. Self-inductance is mu naught N square into volume. This is very, very important statement. So self-inductance of the solenoid is what? Solenoid current is what? Current is flowing. Magnetic field at center is mu naught Ni by 2, mu naught Ni. So due to that flux we are finding, so flux is equal to N into B into A. So mu naught N square I by L into L, you substitute. What we are getting? Inductance is equal to, self-inductance is equal to mu naught N square into volume. This is very important. Self-inductance is volume. Volume is equal to what? Mu naught. This N is equal to N square, total number of turns by L square into volume is A into L. So this is called self-inductance. Self-inductance of the solenoid is mu naught N square by L into A. This is also self-inductance. Self-inductance is mu naught small n square into volume or mu naught capital N square by L into area. If area is increased, self-inductance increased or decreased? Increased. Number of turns are increased. Self-inductance is increased. Self-inductance means, inductance means opposing, change in current. Now this is called inductance. Flux is always, we are defining is L into I. This is always constant. Flux is equal to what? L into I. Now when we are connecting in DC sources, inductor, through resistance, how this current is changing, but switch is closed, EMF is I, R. So current is flowing along this direction. So always you remember I is equal to I naught into 1 minus e power minus t by tau. This is the same concept. Charging at the capacitor, and while we are connecting inductor, initial current is 0, but current at t is equal to 0, inductor always opposes the maximum charge current flown through that. So I is equal to I naught into e power minus t by tau. Now E is equal to what? E is equal to E naught into 1 minus e power minus t by tau only. So voltage drop across this initially is how much now? Initially, sorry. So at t is equal to 0, current flowing through this is how much? 0. Means so resistance voltage drop across this is 0. Now VR is equal to what? V naught into 1 minus e power minus t by tau. Resistance meda. Mari VL is what? V naught into e power of minus t by tau. This is important. L into, so voltage across inductor is equal to L into di by dt. L into di by dt. I is equal to I naught into e power minus t by tau. Tau is equal to what? Time constant. Time constant is equal to L by R. Time constant here is L by R. In RC circuits, CR. Time constant is equal to L by R. In RC circuits, CR. Now you write down this one. So discharging is what? The discharging, this is charging condition only, but current is increasing. In discharging mode is what? Just you take inductor and resistor, just we are connecting through a switch, L, but initial current is there, but R. Now, but always I is equal to what? I naught into e power minus t by tau. So this is what discharging mode. Now, in EMA concept, very important one is, so whenever flux is changing, suppose magnetic field is changing along this direction. So whenever magnetic field is changing along this direction, B is a function of time. Definitely there must be induced EMF. That is what? EMF is equal to what? minus d phi by dt is equal to minus dB by dt into area. Suppose this area is what? A. So EMF is defined as integral E induced dot dl bar. So induced is nothing but what? When we are taking, when our magnetic field is region is varying here only. So this is R. Magnetic field changing. But here we can find an induced electric field. So direction is very important. Induced electric field is equal to, this is dl is 2 pi r minus dB by dt into area which is changing only magnetic field by 2 pi r. If area is pi capital R square, if area is equal to pi r square, in this region only magnetic field is changing, minus dB by dt into pi r square by 2 pi small r. So what you are getting? Minus r square by 2r into dB by dt. This is what induced electric field. This is electrostatic field kaadu, induced electric field. That induced electric field is non-conservative field. Whenever time varying magnetic field producing, time varying electric field is producing, that is induced electric field. Induced electric field is a circuital field lines, but starting point, ending point you cannot say. Where is positive charge and where is negative charge you cannot say. Induced electric field is what? Closed field lines. That is a vortex field form. So non-conservating field. Work done by the electrostatic induced electric field is not zero. Now minus r square by 2r into dV by dt. So when this r is greater than r, this is your formula. R is greater than r, this is formula. R is less than r, r is less than r. This formula turn out to be E star is equal to r is less than r. So definitely your formula is 1 by r by 2 into dB by dt. Just r by 2. R is less than r, dB by dt into minus r by 2. Minus sign indicates that flux is increasing. Suppose flux is increasing in this direction, magnetic field is increasing in this direction, flux is increasing in the direction. To decrease that magnetic field, so whenever flux is increasing in this direction, so definitely induced electric field will be induced concentrically to oppose the change in flux. So flux is increasing. To decrease flux, current should be, induced electric field will be in this direction. Magnetic field is a function of time. Magnetic field is, flux is increasing in this time, flux is increasing. To decrease, current should be, but induced electric field will be along this direction only. So if flux is increasing in this direction, electric field will be what? But and clockwise direction. Magnetic flux is increasing into the plane, the induced electric field will be anti-clockwise direction. So coming out, flux is increasing in this direction, but clockwise sense. Now solenoid concept over, but toroid also just to take values. Now transformer అని ఏసీలో చెప్పాలి రైట్ అండి, జస్ట్ ఇక్కడ చెప్తాను రైట్గా. బట్ ఏందవుతున్నప్పుడు నీకు primary coil and secondary coil both are there, primary circuit, primary and secondary. So here how many turns are there? Here N1 turns are there, here N2 turns are there. So this is output, V output, this is V input. So here resistance is R1, here resistance is R2, V N1, N2. So now flux is what now? Flux is related to N into F. Here flux 1 is equal to flux definitely 2. Flux in this coil 1 is nothing but flux in 2. This is called soft iron we are using. So flux is nothing but L into I. So how much flux is passing through this? Same flux will be there. Rate of change of flux will be what? In the both ways, rate of change of flux is remains same. Is nothing but minus V1 by N1. But how much flux is changing? Here also change in flux same. Is equal to what? Minus V2 by N2. So V input is equal to what? V input is equal to N1 by N2 into V output. Now you tell me V output. V output. Now if number of turns in primary coil is more, V input by V output is equal to N1 by N2. This always remember. If primary circuit number of turns is more than secondary circuit, so V2 must be less than V1. That is called step down transformer. Input voltage is 1000 volts, but I want less than that, step down transformer I use. So V1 by V2 is equal to N1 by N2. So secondary source, secondary circuit turns are less than primary circuit, definitely step down transformer. Step up transformer is what? If input number of turns is less than output, if N1 is greater than N2, step up. N1 is N1 is greater than N2, step down. So N1 is less than N2, step up. Step up and N2 will be more than that. So output voltage is more than input voltage, but power is remains same. V input, I input is equal to V output and I output, always same. Power will be, but we cannot create more energy, we cannot destroy more energy. But how much energy we created, same energy we can use, but not more than that. So V input and I input is equal to V output and I output. So power will remain same. So when we are using power, I input is V square by R only. So now R input by R output is equal to N1 by N2 whole square. This also you remember. Resistant input and output is also R N1 by N2 whole square. So V input by V output is equal to what? N1 by N2. If N1 is more than N2, step down transformer. If N1 is less than N2, step up transformer. Final voltage is more than initial voltage. So final voltage is less than initial voltage. Step down, step up. So resistance input and output also N1 by N2 whole square. Clear? Next, AC. AC is what? So when resistor is connected in AC source. So AC source means what? Voltage sources. V is equal to what? V naught sin omega t. Or I is equal to I naught sin omega t or cos omega t I can take. So when we apply, but current and voltage both are same, V by R. Is it V by R? Sin omega t only. So V is equal to what? V naught sin omega t. So both are having same phase. But when we are connecting resistance to the AC sources, both are having the same phase. Both are in same phase. Current and voltage both are in the same phase. We can show phasor like this. V is more and E is less because V by R govern. Now when we connect, the power consumed by the resistance is what? Power consumed by the resistance is what? V is equal to, power is equal to V square by R or V into I. V into I. So, but power is V into I is the power. So, power dissipated or power consumed will be V into I. So, how to calculate? V into I calculate. V into I is what? V naught, I naught, sin square omega t. Power is sin square omega t. Now, before coming to this, V is equal to V naught sin omega t, I is equal to I naught sin omega t, we are taking cos omega t also you can take. RMS value, how to calculate? RMS value is equal to under root. RMS means square mean root. Square mean root. V naught square sin square omega t square mean root. So this is what? V naught by root 2. So we are getting RMS value always you find out. What's the difference between AC and DC? AC is what? It's alternating current, but it is varying from plus to minus via 0. Now, but DC means what? Direct current. But some fluctuations are there in AC current. But in one direction it can produce, but RMS value is what? Always you take. When we connect one resistance in DC source, but power is consumed. Some power will, some heat is liberated. The same time when we are connecting AC sources, but it is also giving the same heat when we are taking V naught by root 2 value. So always you take AC and DC, but with respect to resistance we are finding. So RMS value is very important. So mean value is what? Average value is half cycle average value. V naught sin omega t. Average value over the whole full cycle is what? 0. Because sin omega t function is 0. Average of sin omega t is 0. Average of sin square omega t is what? 1 by 2. Average of sin square omega t is 1 by 2. P average is what? P average is sin square omega t average value is 1 by 2, V naught, I naught by 2. So we can write V naught by root 2, I naught by root 2. So V naught by root is RMS value, I naught by root is RMS value. So power consumed with the resistance when we connect it to AC source is VRMS into IRMS only. VRMS into IRMS. Now RMS value how to calculate? Square mean root. Square mean root. So when we connected inductor to AC source, what happens? Inductor always, voltage across inductor is always leads the current. So V naught sin omega t plus pi by 2. So voltage, current is equal to what? Is equal to I naught. So sin omega t. Always you remember. So current passing through inductor lags the voltage by pi by 2, or voltage in the inductor leads the current by pi by 2. So when you take capacitor, so voltage across the capacitor lags by pi by 2. V naught sin omega t minus pi by 2, or I is equal to IC. I naught sin omega t only. See, always remember. In capacitor, when capacitor is connected, current leads the voltage. When only inductor connected, voltage leads. So, but why we are getting? Because of, but inductor and capacitor both are depends upon omega. So resistance of impedance is what? Inductance. Inductance is capacitive inductance means 1 by omega C. Resistance offered by the capacitor connected to AC sources. L is what? Omega L. So resistance offered by inductor when we connected in AC sources, omega L, and X is equal to omega C. So you remember. So I naught is what? I naught is V naught by X L or XC. So that is called impedance. Impedance ante inductance, inductive reactance is different, and impedance is the impedance is total resistance offered by the capacitor or inductor whole square plus R square. This is called impedance. XL minus XC whole square plus R square. That's called impedance. Total resistance offered. Now, always current is what? V by Z only. Now onwards we are using this called impedance, total resistance, V by Z. So whenever resonance is happening, resonance means what? XL is equal to XC. XL is what? 1 by omega C, 1 by omega L is equal to 1 by omega C. So omega square is equal to 1 by LC. So omega is equal to 1 by root LC. So whenever the external voltage frequency, external source frequency and but internal frequency are matching, then resonance will be happening. At resonance, Z becomes what? Z is equal to always XL minus XC whole square plus R square. If XL is equal to X at resonance, so XL is equal to XC, but impedance is nothing but what? Simply resistance. Current in the circuit is maximum. That is called peak current we are getting. So we are getting like this. So as omega is equal to, omega naught is equal to 1 by root LC. So quality means, quality are defined as the XL by R or XC by R at resonance frequency. So XL is what? Omega naught L by R, or omega 1 by omega naught CR. Even this coach. Quality means, so XL by R at resonance. 1 by root LC into L by R, or 1 by root LC into CR. కాదు అంతేనా? కరెక్ట్. సో ఒమేగా ఎక్కడ కదా రాయాల్సింది? రూట్ ఎల్సి. నా చెప్పండి ఎంత అవుతుంది వాల్యూ? రూట్ ఎల్ బై సిఆర్ 1 బై ఆర్. ఇక్కడ కూడా ఎంత అవుతుంది? రూట్, రెండు సేమే. సో వీ కెన్ టేక్ దిస్ వన్ యాక్చువల్. ఓకే, క్యూ ఈజ్ ఈక్వల్ టు వాట్? XL by R at resonance condition. Resonance is what? 1 by root LC. Omega is equal to 1 by root LC. So, sharpness is only depending upon just sharpness increase అవ్వాలంటే ఏమవ్వాలి, sharpness means at resonance condition only. So already you know quality factor also, you know resistance should be small, C should be more, L should be but more quality, L should be more, resistance is less, C should be less. So now I am giving you two currents like this. So I1 and I2. So R1 and R2, which one is greater? So current is more, resistance is less. Definitely R2 is less than R1. R2 is less than R1. Now up to AC, no problem. Up to AC, you read. But if any problem is, just continuous class and custom. Okay? But modern physics and everything, you read that. Okay? But can I teach optics also? Optics? Optics, come to optics. Optics. We have real object and object. Just to take a mirrors, concave mirror. Focal length is what? So this is what? But always you remember the mirror's formula is what? 1 by F is equal to what? 1 by V plus 1 by U. So take sign convention. Along the ray direction from the pole you measure positive direction, otherwise opposite that negative direction. So when we are taking this, so instead of taking pole, Newton formula is there, but just not from the pole. We are finding the position of the object and image from focus. We are finding the position of the object and focus from the pole means both are real and real only. Newton formula is applicable for real object and real images only. That is what? From the pole, object distance is x1, image distance is x2. So definitely x1 into x2 must be equal to f square. Newton formula. Instead of taking pole, we are measuring from focus. So x1 and x2 must be equal to f square. V becomes what? F. 1 by f is equal to 1 by f plus x2, 1 by f plus x1, like this. So just the formula is what? Generally we are taking this one only. So magnification is defined as what? Minus V by U. So magnification means it can be more than object size or less than object size. So minus V by U. Why we are keeping minus sign? But after reflection rays are coming to the same medium. So this is what? Minus V by U. So always remember magnification. If object is at 3f by 2, image is at 3f. Object is at 4f by 3. Object is at image is at 4f. So magnification is 3 times. Atla. Mari eppudina oka formula direct substitution you will get. So plane mirror also like that. No.